Hello there. It's so nice to have you back, and thank you for drifting in again with us tonight. Tonight we're not looking up at distant galaxies or ancient stars. Instead, we're turning our gaze towards something closer, and yet, perhaps, stranger, a traveler from another star system called 3I, Atlas. It has no eyes, no voice, no flag, and yet, for weeks now, it's been quietly rewriting what scientists thought they knew about how the universe behaves. Harvard's Avi Loeb just gave it a 7 out of 10 on his technological origins scale. That's a 70% chance that what we're watching isn't natural, not a rock, not a comet, but something else. Imagine standing outside on a cool night, looking up. Somewhere, beyond Mars, an object the size of a mountain is gliding through the dark, turning from red to green, venting pure nickel into space, like a slow metallic breath. The air around you feels ordinary, but out there, in the vacuum, something extraordinary is unfolding, silent, deliberate, unexplainable. It isn't behaving like any comet ever seen. It's releasing elements that don't form together in nature, as if it were built rather than born. Now picture that. A craft or a coincidence crossing our solar system while the world argues about what it even is. Amateur astronomers swear they've photographed sharp edges under its haze. NASA calls that impossible, but every telescope that looks at it comes back more confused than before. It's as if the laws of physics have taken a sick day. Maybe you're listening to this late at night, phone on your nightstand, the day behind you. Funny, isn't it? A billion-year-old traveler from another sun is passing by right now, and somehow, you and I get to share the same quiet second of its story. If you like, tell me in the comments where you are and what time it is. It's oddly comforting to see those little coordinates of curiosity appear from around the world. So dim the lights, pull the blanket up, and get comfortable, because what's coming next is equal parts science, speculation, and something that feels a bit like science fiction, except the data are real. What does it mean when an interstellar object behaves as though it knows we're watching? Could something artificial really be drifting through our neighborhood, and why now? Or is this all just nature, flexing her sense of humor at humanity's expense? Whatever it is, the odds just changed. 70% chance of the unexpected. And to understand what that means, we'll have to start not with panic or proof, but with the quiet story of how a small, cold object from another star became the biggest mystery in the solar system. It began like all great mysteries do, with a dot, a faint speck moving against the background of stars, just another candidate in a sky full of them. But the math didn't fit. Its speed, its path, its chemical fingerprint, none of it matched a normal comet. It was as if something had entered the solar system on purpose, not by chance. Let's start with that moment. A single pixel on a telescope screen, blinking softly, like a heartbeat in the void. You can almost hear the low hum of the observatory, the soft click of cooling fans, the faint rustle of paper as an astronomer shifts uneasily in a creaking chair. The air smells faintly of metal and stale coffee. The night feels thick, electric, and quiet. The kind of quiet that makes you aware of your own breathing. There it is again, the dot, small and stubborn, gliding across the frame with the calm confidence of something that knows exactly where it's going. You blink, rub your eyes, check the numbers, and they refuse to behave. That's how these things begin, not with drama or lightning, but with one tiny thing in the universe refusing to do what it's told. The next morning, you check again. The dot has moved, but not like a rock, tumbling randomly through the dark. It's too clean, too graceful. It's traveling at 137,000 miles per hour and yet seems somehow composed, like a ballet dancer crossing a stage that just happens to be space. You lean closer to the screen, hypnotized. It's not spinning wildly, it's gliding, and the thought creeps in, what if it's not a comet at all? The data keeps arriving, mostly carbon dioxide, almost no water, pure nickel emissions with zero iron. In the cosmos, nickel and iron are twins, born together in dying stars, fused in fire, and scattered into every meteor and planet we've ever known. Finding nickel without iron is like finding smoke without fire, or pancakes without syrup. It doesn't happen in nature. Unless, of course, it's not nature doing the cooking. Soon, the astronomers name it 3I Atlas. The letters and numbers sound clinical, but together they carry a kind of accidental poetry, like a coded message from the void. It's not big 5 kilometers across, maybe, but that's large enough to rewrite textbooks and ruin a few planetary mornings if it came any closer. Fortunately, it won't. Probably. The math says so, though math has a reputation for optimism when the universe decides to get weird. You imagine the object now, streaking through space like a shard of obsidian ice, sunlight glancing off its surface as it passes the orbits of Mars and Jupiter. Its faint tail doesn't drift lazily behind, like a comet's usually does. It points forward, as if something inside it were pulling, guiding, steering. Scientists frown at words like artificial. They prefer terms like anomalous, unusual, or the ever-popular requires further study. But in quiet corners, even the skeptics admit it's unsettling. You picture the meeting rooms, sleep-deprived researchers gesturing at spectral graphs, murmuring about nickel ratios while trying not to sound excited. One of them laughs nervously and says, "If it's aliens, I'm retiring." Another one replies, "If it's aliens, you're getting a promotion." Outside, the night remains serene and indifferent, the stars glinting with their usual ancient patience. Imagine standing beneath that sky. The air is cold, the world around you asleep, and above you, that tiny traveler sails past, its green glow faint but alive. You can't see it with your eyes, not really, but you can feel the idea of it, the thought of something old, deliberate, and far from home, passing silently through your neighborhood. It doesn't announce itself. It doesn't wave. It just goes. And that makes it even stranger, because the universe, vast and wild as it is, rarely sends visitors that behave like guests. Most comets are sloppy. They spew ice and dust like drunks at a fireworks show. But 3I Atlas moves with purpose, as if following instructions written in a language older than gravity. You breathe out slowly. Maybe it's nothing. Maybe it's just a rock, an odd one. Sure, but a rock nonetheless. Then again, maybe it's something built, something designed to travel between stars, the way ships once crossed oceans. If so, it's not the first traveler, just the first we've noticed. And that thought is the most human one of all. Not fear, not certainty, but curiosity, the quiet itch that keeps you staring up long after you should have gone to sleep. You can almost hear the universe whispering back, patient and amused. For all our telescopes and algorithms, maybe it still likes to keep a few secrets. So, as you lie back and let your thoughts drift, remember, this story began with a dot, no bigger than a pixel, blinking softly against infinity. That's all it takes to change how we see everything. The object that shouldn't exist is still out there, moving at its own pace, unbothered by what we believe. Maybe it's natural, maybe it's not. But tonight, As the hum of the earth fades into background silence, you realize the truth doesn't matter quite as much as the wonder it leaves behind. When Avi Loeb quietly raised his rating to 70% technological probability, it sent a ripple through the astronomy world like a stone dropped into a still pond. The man who once called Oumuamua artificial had done it again. Only this time, the data were stranger, more stubborn, and harder to ignore. Nickel without iron, gas with no water, a trajectory that felt tuned instead of tumbled. Scientists around the world tried to laugh it off, but there's only so long you can laugh at numbers before they start laughing back. Imagine you're in Loeb's office in Harvard bookshelves, heavy with titles about black holes, a coffee cup orbiting the edge of a paper stack, and that quiet hum of an overworked computer keeping time with the rhythm of the universe. Outside, the night presses against the window, and somewhere between the hum of the radiator and the whir of the cooling fan, you hear the soft electric thrill of possibility. You lean in, checking the data again. The object's composition defies stellar logic. Its velocity makes no gravitational sense. And the math, oh the math, is both terrifying and delicious. To give something a 70% chance of being technological is like telling the world there's a 70% chance that your toaster is whispering back. It's absurd. It's bold. And yet, Loeb's voice, calm and unshaken, carried the weight of a man who had already weathered ridicule once before. He didn't claim certainty. He never does. Instead, he gave the universe a raised eyebrow and a gentle, academic smirk, as if to say, I don't know what this is, but don't pretend you do either. You can almost picture him walking down the hallway, the fluorescent lights buzzing softly above, while his colleagues exchange wary glances like nervous villagers in a sci-fi movie just before the sky opens. It's not that they don't believe in anomalies, it's that they don't like what anomalies do to funding proposals. You, sitting here listening, can almost feel that tension, the pull between curiosity and caution. One side whispers, "What if?" The other hisses, "Don't be ridiculous." Loeb lives somewhere between those two voices, right where science becomes poetry and skepticism becomes faith. His office smells faintly of dust, chalk, and rebellion. On the screen before him, the spectral data hums like a lullaby written by atoms. Nickel lines flare bright, clean, and alone. No iron, no trace, no sibling elements. Just a cold metallic purity shining from billions of kilometers away. He writes a line in his notes, "Industrial signature possible." The phrase looks innocent, but it detonates quietly in the mind. Industrial, manufactured, artificial. These are words you don't just toss into a research paper unless you're ready for your inbox to explode. Loeb is used to that now. Ever since Oumuamua in 2017, when he dared to say, maybe it's technology, he's become astronomy's polite heretic. Every time he speaks, you can feel the collective clench of cautious scientists bracing for headlines, but he doesn't seem to mind. Maybe he knows that curiosity is always louder than conformity, even when whispered. Picture the scene a few days after he publishes his new analysis. Somewhere in a conference room, a dozen astronomers hover over a projection of 3 I-Atlas's trajectory, red laser pointers circling the screen like nervous flies. One of them mutters, "It's a comet," while another adds, "It's an interstellar oddball." Then someone in the back says it, quietly but firmly, or "It's not natural." The room goes still. There's always that moment right before laughter, before denial, when everyone realizes they might be looking at something history will remember. The silence stretches, fragile and golden, before it collapses under the weight of rationality. Well, someone says, clearing their throat, let's not get ahead of ourselves. And just like that, the mystery is pushed into the folder labeled inconclusive, where humanity keeps all its greatest fears. But Loeb doesn't put things in folders. He keeps them open, alive, whispering. To him, the universe isn't a museum of certainties. It's a conversation with a trickster. And tonight, the trickster's name is 3I Atlas. It doesn't roar. It doesn't flash. It glides, quietly, methodically, like something testing us. Every telescope that turns toward it finds new puzzles. The ratios change, the colors shift, and the closer it gets to the sun, the more it behaves like it knows what the sun is. You can't help but smile at the absurdity. A comet that thinks, why not? The universe has given us stranger guests. In the quiet of your room, as you picture Loeb leaning back in his chair, you realize something unsettling, but oddly comforting. Science, at its best, isn't about knowing, it's about daring to wonder. It's about standing under a sky full of equations and asking, what if? The answer might never come, but the asking is what keeps us awake and what eventually, gently, puts us to sleep. Somewhere out there, 3I Atlas continues its steady path, a glowing question mark sailing through space, while down here, one man's 70% has turned the cosmos into a dream that refuses to end. In the universe, nickel and iron are inseparable twins. You don't get one without the other unless you built it that way. The spectrum of 3I Atlas glowed with nickel lines, crisp and metallic, but no iron anywhere. It was like finding a fingerprint made of pure alloy. Let's start there, with that impossible absence. Imagine the James Webb Space Telescope peering into the darkness, its mirror segments gleaming like golden petals catching ancient light. Somewhere in the data stream, a quiet spike appears at the wavelength of nickel, sharp and defiant. Another wavelength, where iron should be singing its matching tune, lies silent. It's the cosmic equivalent of a duet where one singer never showed up. You can almost picture the scientists staring at the graph, blinking, waiting for iron's voice to appear. But the silence only grows louder. In every stellar furnace, in every cosmic explosion that births matter itself, nickel and iron are forged together. They're the inseparable couple of the periodic table partners born in the same supernova, locked in chemical matrimony since the dawn of stars. They condense, travel, collide, and settle together in asteroids, meteorites, and planetary cores. Even the nails in your desk and the blood in your veins owe something to that fiery union. And yet, 3I Atlas seems to have broken the rules. Nickel without iron, it's like baking bread without flour, or making coffee without bitterness. Nature doesn't do that, not unless something, or someone, gave it a little help. You lean back, eyes closed, imagining the object itself, a lump of reflective metal drifting between worlds, slow and ancient, its surface etched with the scars of uncountable collisions. Sunlight catches on it and scatters in greenish hues, flashing across the void like a distant signal. Maybe it's natural, yes, but even natural things can be unsettlingly precise. Maybe it's coated, refined, engineered by time or temperature into this improbable purity. But the human brain, your brain can't help noticing how clean it feels. It doesn't feel random. It feels made. Loeb's paper was cautious, of course. Scientists always are when the evidence starts whispering science fiction. He described a highly unusual spectroscopic profile, which in academic language translates to, "We have no idea what's happening." but it's probably bad for someone's career. He mentioned the possibility of nickel carbonyl compounds forming in the cold of interstellar space molecules that could, in theory, mimic industrial purity. But in theory is a delicate phrase, like a waiter describing the soup as interesting. It means nobody's tasted it before, and if they have, they didn't enjoy the aftertaste. Imagine the absurdity of it. Entire teams of world-class astrophysicists staring at a graph that looks like a metal detector pinging in the void. One of them jokes that maybe it's a spacecraft shedding armor plates. The others laugh politely, then look back at the screen, the laughter dying slowly, because the data doesn't care about how polite you are. The data just hums, steady, insistent, nickel without iron, line after line, as if the universe itself were tapping a finger on the table saying, "Notice this. Now picture yourself standing on an airless plane beside it. The sky is black, the stars unnervingly still. Before you lies Three-Eye Atlas, dark, massive, indifferent. You reach out and touch its surface. It's cold, smoother than stone, but harder than anything you've known. It doesn't crumble like ice, doesn't flake like rock. It feels deliberate, as if someone once shaped it with purpose. The airless silence presses against you thick as velvet, and for a brief second, you could swear you hear a hum, a slow vibration, deep in your bones. Maybe it's just your heartbeat echoing in your helmet. Or maybe it's something older, something that's been waiting a long time to be touched. Back in the lab, scientists start comparing notes. They look at historical records of every comet, every asteroid ever sampled. Each one shows the same thing: nickel and iron, hand in hand. There are no exceptions. Until now. Some whisper the word manufactured in hallways and message boards, half as a joke, half as an offering to curiosity. Others recoil from it, afraid that acknowledging the possibility would mean stepping off the map entirely. After all, it's easier to laugh at mystery than to live with it. And yet, the more they look, the stranger it becomes. The ratio of nickel increases as the object nears the sunday. That's not random heating, it's reaction. The more light it absorbs, the more metal it releases, as if sunlight were waking something dormant inside. You can't help but imagine it a metallic chrysalis unfurling after eons in the dark, shrugging off dust like sleep. The universe may not build factories, but it has built stranger things. By midnight, the observatories fall silent. The data has been checked, rechecked, scrubbed, and questioned, but the lines don't lie. Nickel without iron, nature without precedent, a fingerprint without a hand. Maybe it's an artifact from a civilization long gone. Maybe it's a fluke of chemistry from a star system that died before Earth was born. Or maybe, just maybe, it's both something born natural, made artificial by time itself. You breathe out and smile. Whatever it is, it's proof that the universe still knows how to surprise you. And maybe that's the real story here. Not that Three-Eye Atlas breaks the rules, but that it reminds us rules are only temporary, until the cosmos decides to write new ones. On July 12th, the comet looked red, dull, dusty, textbook. By morning, it was glowing green, its chemistry transformed. Even Webb's instruments blinked. Some called it gas fluorescence. Others whispered of something self-regulating, almost reactive, as though the object were alive, or at least paying attention. Let's drift into that night. Imagine the great observatories of the world staring upward, their domes humming softly like enormous sleeping animals. In the quiet of Mauna Kea, a technician sips cold coffee, checks the spectral data once more, and frowns. The graphs are shifting color. The glow that was once muted, rusty red like embers under ash, now pulses with a vivid emerald light, sharp enough to tint the telescope's reflections. In the language of data, that means molecules are dancing differently now. But in the language of wonder, it means the universe just changed outfits overnight. You can almost smell the cold metal of the telescope railing as you lean forward, trying to picture it. A comet shouldn't be able to do this. Color is chemistry, and chemistry doesn't just wake up and decide to be artistic. And yet here we are, something deep inside. 3i Atlas has turned on, like a bioluminescent switch. Its tail, once a lazy swirl of dusty red, now shimmers in sheets of green gas, glowing faintly against the velvet dark. The astronomers log it as fluorescent response to solar radiation, but that's a technical lullaby, the kind of phrase scientists use when they don't want to say, "This shouldn't be happening." Maybe it's the simplest explanation: molecules absorbing sunlight and re-emitting it at new wavelengths. But the green isn't fading, it's intensifying. The longer the object approaches the sun, the more brilliant it becomes, as though it's feeding on light instead of reflecting it. It's almost funny. In a quiet, cosmic way, humanity builds billion-dollar telescopes to study the universe, and the universe responds by giving us a glowing space marble that behaves like a mood ring. Imagine standing outside beneath that sky. The air is cool, the stars faint. Somewhere out there, hundreds of millions of kilometers away, a green flame is drifting silently through the void. You can't see it with your naked eye, but knowing it's there changes how the night feels. The darkness doesn't feel empty anymore. It feels occupied, awake, and if you listen hard enough, you could almost imagine it breathing. The news spreads fast. Amateur astronomers scramble to capture the change. Twitter fills with images, grainy, luminous dots surrounded by ghostly halos. Some insist it's camera error, a trick of exposure. Others swear it's real. The forums turn into digital campfires, strangers trading theories, and caffeine-fueled awe. One user writes, "It's reacting." Another jokes, "What if it's charging?" No one laughs for long. Back in the lab, the data tells its own quiet story. The ratio of carbon to oxygen shifts subtly overnight. Cyanide levels spike. There's structure in the emission lines, a pattern, faint but rhythmic, like a repeating pulse. Someone points it out in a meeting, hesitant, then deletes it from the slide before presenting. Because the idea that something millions of kilometers away might be doing something rather than having something done to it, that's a dangerous thought in science. Picture it now, as Webb sees it, an emerald mist, unfurling like breath in the cold. The object's surface is hidden beneath the glow, as if wrapped in a veil of reactive gases. The color isn't random, it's steady, consistent, deliberate. Even when the viewing angles change, the hue remains pure. No flicker, no fade, just green, life's favorite color. The color of chlorophyll and chemistry, of energy stored and released. The color of self-preservation. Maybe it's coincidence. Maybe sunlight hits the surface and wakes up ancient molecules frozen since before the dinosaurs. Or maybe, as some quietly joke, it's the comet's way of saying, hello. You can't help but smile at the absurdity. If space ever wanted to flirt, this would be the way: subtle, mesmerizing, a touch theatrical. Scientists, of course, rush to model it. Equations fill whiteboards, numbers spill across monitors, simulations run until dawn. But none of them explain why the change was so sudden, why the green stayed stable when it should have fluctuated. It's as if 3i Atlas didn't just react, it adapted. And that word, adapted, sits in the room like an unwelcome guest. You don't use it for comets, you use it for living things. Now close your eyes and imagine floating beside it. The glow envelops you, painting your suit in emerald light. Each particle in the airless space seems to hum, a faint vibration that tickles your skin even through the vacuum. You reach out, and the light ripples like liquid glass. It feels almost warm, almost curious. You whisper to no one, "Are you awake?" And for a moment, in the silence of space, it feels like it whispers back. By morning, astronomers around the world agree on one thing. Whatever's happening, it's beautiful. Terrifyingly beautiful. It's as though the universe decided to remind us that it still holds colors we haven't named yet. And while the scientists argue, and the data streams, and theories unravel, you can't shake the feeling that somewhere out there, 3i Atlas is smiling in its green disguise, watching us watch it, and enjoying the attention. While official observatories shuffled paperwork, backyard astronomers pointed their telescopes and captured something no one expected. Structure, not a haze, not a blurred geometry, edges where there shouldn't be edges. The forums went wild. Science called it noise, but noise doesn't cast shadows. Let's slip into that moment. 1,000 sleepless amateurs across the planet, scattered under different skies, all united by the soft hum of cooling fans and the hopeful glow of laptop screens. Picture one of them, a quiet man in rural France, wrapped in a blanket, sipping instant coffee as his telescope tracks 3i Atlas inch by inch through the heavens. His garden smells faintly of grass and cold dew, the air shimmering with mosquitoes and ambition. The stars above him are steady, but his monitor isn't. He zooms in, and there it is. Something sharp in the middle of the blur, something solid beneath the gas. He blinks, checks again, adjusts the focus, and there again, a sliver of symmetry. Somewhere in Texas, another observer notices the same thing. Then one in Namibia, then one in Japan. They don't know each other, but within hours, they're posting to the same forums, their excitement bleeding into every thread. Do you see it too? Am I losing my mind? Or does this look like a shape? Edges, actual edges. It spreads like wildfire through the digital night. By the time the sun rises, the internet is alive with speculation. One user swears they see a hexagon. Another insists it's a triangle, like a spacecraft venting gas. A third, sleep-deprived and over-caffeinated, declares that the universe has finally sent its business card. Screenshots multiply like spores. Hashtags bloom. Someone even makes a meme, Comet or IKEA shelf. In the professional world, the reaction is less poetic. At observatories, eyebrows arch and dismissive sighs fill control rooms. Artifacts, someone says, waving a hand. Exposure errors, motion blur. It's the polite scientific equivalent of patting the internet on the head. And yet, deep down, even the professionals are curious. Because here's the problem. These amateurs aren't using toys. Modern backyard telescopes rival what state-funded observatories had 30 years ago. They're precise, sensitive, and utterly relentless. You can shut down a lab at night, but you can't stop thousands of hobbyists armed with caffeine and Wi-Fi. Imagine scrolling through the images yourself, some grainy, some startlingly clear. Against the soft glow of the gas envelope, there's a glint, a crisp line that shouldn't exist in nature. Comets are messy, fuzzy, disorganized. They are chaos incarnate. This, though, looks tidy, intentional. It's as if someone took the wildness of space and straightened it with a ruler. You lean closer to your screen, your eyes watering from the light. The thought creeps in quietly. the way forbidden thoughts often do. What if it's not a comet? What if it's something else wearing a comet's coat? Back on the forums, the debate grows louder. A retired engineer posts a detailed breakdown of diffraction patterns. A teenager counters with a sarcastic gif of an alien waving, "Hello." The world's largest community of armchair scientists becomes a modern-day bonfire of curiosity. Each post, another spark against the dark. "It's just pixel noise," one professional writes in a comment thread. "Then why does the noise have corners?" someone replies. There's no answer. Not yet. And then, as always, comes the silence. The kind that hums louder than any argument. Because the more people look, the more convincing it becomes. Patterns emerge where randomness should reign. The geometry repeats between frames, across time zones, across hemispheres. That shouldn't happen if it's just error. Errors are chaotic. This feels rehearsed. Imagine those amateurs at dawn, sitting in their gardens and garages, surrounded by buzzing computers and half-empty mugs, staring at their findings with the half-delirious awe of someone who's seen something they can't explain. They don't call themselves discoverers. They don't need to. The act of looking, of catching the universe doing something strange, is reward enough. You can almost hear their collective heartbeat under the static of the Webb. Thousands of minds holding their breath at once. Meanwhile, the official astronomers prepare their statements. The data are inconclusive. The images show processing anomalies. Nothing to see here. But that's the thing. There is something to see, even if no one knows what it is. The amateurs don't have the credentials, but they have something better. Freedom. No institution, no grant, no peer review. Just wonder, and wonder is a dangerous thing in a world addicted to certainty. By the end of the week, the story fades from headlines, buried beneath more terrestrial dramas. The forums quiet down, the memes slow, and the world moves on. But the images remain stored on hard drives, printed on glossy paper, hung above desks like personal relics of the unknown. Every now and then, one of those backyard astronomers will open the file again, zoom in on the faint geometric shimmer, and feel that same electric hum of curiosity pulse through their chest. You, too, can feel it now. The thrill of seeing something the experts missed. The quiet rebellion of wonder against authority. The night sky has always belonged to those who look up, not those who explain it. So maybe that's what the amateurs gave us, not proof, but permission. Permission to believe, if only for a moment, that the universe still has edges sharp enough to catch the light. And maybe, just maybe, they caught one of them. On October 3rd, 3I Atlas passed within 29 million kilometers of Mars, closer than any interstellar object has ever come. Officially, nothing unusual happened. Unofficially, dozens of sensors picked up faint electromagnetic pings, dismissed as background. The timing, though, was perfect. Too perfect. Imagine it. The red planet turning slowly in the black, a dusty marble in an infinite sea, while this visitor from another star system drifts past like a quiet ship at dusk. It's easy to picture the NASA control rooms that night, monitors glowing, headsets hissing with static, engineers staring at telemetry that makes them sit up a little straighter. Somewhere in the silence, an instrument meant to measure nothing at all begins to hum. A blip, then another, too regular to be random, too faint to be meaningful, or at least, that's what the report will say. If you'd been standing on Mars that night, say, next to Perseverance in Jezero Crater, the sky would have been an oily red-purple wash. The air so thin it feels like a ghost brushing against your suit. the horizon flickering with dust devils and frozen light. You look up, and for just a moment, something glints against the stars. It's faint, but steady, moving with a confidence that doesn't belong to debris. The silence presses against your helmet like held breath. For billions of years, Mars has been the observer. Tonight, something else is doing the watching. Back on Earth, the official statements are clinical, trimmed, and tired. Routine flyby, expected readings, no anomalies detected. You can almost hear the shrug in the phrasing. And yet, the internal memos tell another story. Leaked snippets of telemetry showing magnetic fluctuations that repeat every 43 seconds. Too rhythmic for solar interference, too gentle for cosmic rays. It's almost like communication, but that word is radioactive in the scientific lexicon. The moment someone says communication, you might as well say career suicide. So instead, they call it a patterned fluctuation of uncertain origin, which is bureaucracy's way of saying, we don't know, and we wish we hadn't noticed. Meanwhile, amateur radio enthusiasts from Chile to Finland report strange bursts around the same frequency. Short, stuttering pulses like a heartbeat trying to find its rhythm. They overlap perfectly with the timeline of the flyby. Conspiracy forums light up like Christmas trees. Half the internet convinced we've just intercepted an alien ping. The other half convinced the first half needs more sleep. You scroll through the posts, equal parts amused and uneasy, because deep down, you know coincidence has limits. Now picture the orbit itself. 3i Atlas, threading the cosmic needle, crossing the Martian plane with a precision that would make a spacecraft engineer jealous. Its trajectory cuts just above the thin atmosphere, where solar winds meet magnetic field. The math says the odds of such an alignment by chance are about 1 in 500. You start to wonder if chance even belongs in this conversation anymore. Aboard Mars Reconnaissance Orbiter, the high-rise camera waits for its scheduled imaging window. Its task, capture a faint dot in the distance. But the dot doesn't stay where it should. It's off by half a frame, tiny but measurable. The team rechecks the pointing data, recalibrates the software, and quietly decides to delete that part of the report. The next image lines up perfectly, as if 3i Atlas corrected itself. That shouldn't happen. You can't correct a comet, but you can steer a ship. Imagine the tension in those rooms when the data comes in. One technician notices the lag, another notices the pulse. No one wants to be the first to say it out loud. Someone eventually jokes, maybe it waved, and the laughter is too quick, too nervous. They'll all write it off later as instrumentation error because the alternative is unpublishable. Still, there's that lingering feeling, the sense that something out there noticed us noticing it. And while the world sleeps, a different kind of observer, the rovers, the orbiters, the silent satellites records everything. The ExoMars Trace Gas Orbiter detects a brief chemical spike in the upper atmosphere, an increase in ionized particles, inconsistent with solar wind activity. NASA labels it ambient interference. But it happened exactly when 3i Atlas reached its closest approach. You can almost feel the absurdity of it all. Humanity, a civilization that can barely keep Wi-Fi stable on Earth, suddenly trying to interpret whispers from a comet that may or may not be a machine. We point antennas into the void and call it science, but deep down, it's prayer. The Mars flyby becomes another story, buried in the data archives, folded neatly into the bureaucratic bedtime of scientific caution. Still, you can't help but think, if something or someone wanted to test our attention, this would be the perfect way to do it. slip past our telescopes under the cover of expectation, send a signal too faint to prove, too rhythmic to ignore, leave us arguing in the dark. By the time Mars rotated out of alignment, the pings had stopped. The silence that followed felt intentional, and so, the flyby passed into history as an uneventful encounter, an interstellar visitor politely ignoring its hosts. But you can almost see it now, drifting away from the red planet, its green shimmer fading into shadow. The hum of radiation subsides, the instruments fall quiet, and yet, somewhere beneath that quietness, there's the faint echo of a question unanswered, a rhythm that might have been a heartbeat or a hello. Then, as if on cue, it vanished. For 2 months, 3i Atlas hid behind the sun, unreachable, unseeable, untouchable. Astronomers groaned at the bad luck, but Loeb wondered aloud, what if it wasn't luck? What if it planned to hide when our eyes were busiest? Let's drift into that quiet stretch of time, the long silence when the world's most powerful telescopes went blind. It was late September, and the object that had captured every sleepless scientist's imagination slipped perfectly into the blinding glare of the Sunday. From Earth's point of view, it simply ceased to exist. You can almost hear the collective exhale from observatories around the world. After months of obsessive tracking, the sky had swallowed its mystery whole. But behind the calm official statements, you can sense the unease. Because vanishing is one thing, vanishing on schedule is something else. Picture the solar disk, immense and roaring, a star of unrelenting brilliance. Its surface boils with plasma waves taller than continents, its heat tearing light into colors you'll never see. And there, somewhere beyond its edge, 3i Atlas passes into invisibility. If it were a comet, it should have been shedding more material as it neared that heat, brightening into a glorious tail. Instead, it dimmed. It went quiet, as if it didn't want to be found. Astronomers hate coincidences. This one was too neat, too symmetrical. Its disappearance coincided almost exactly with the point of maximum interest, the moment when its behavior could have revealed everything. Instead, the sun became its shield, and Earth's instruments became blindfolds. Imagine sitting in one of those mission control rooms. The coffee's gone cold, the air smells faintly of dust and ozone, and every monitor shows the same message: no new data. Someone jokes that 3i Atlas just wanted privacy. Someone else doesn't laugh. You can't study what you can't see. And for 2 long months, the object hid in a light so bright that even curiosity couldn't penetrate it. The scientists at NASA and ESA called it a natural solar conjunction. Loeb, ever the contrarian poet of astrophysics, called it convenient. What if, he mused, it wanted to vanish? You imagine him pacing his office, the walls lined with chalkboards, filled with equations that look like spells. Outside, the night hums. He runs a hand through his hair, staring at the orbit diagrams glowing on his monitor. If it were natural, he mutters, this is statistically absurd. He's not wrong. For an interstellar object to align so perfectly with the sun's glare during its most observable phase is an event so improbable it borders on performance art. If space had a sense of humor, this would be its punchline. Meanwhile, other eyes kept watching not directly, but sideways. The Parker solar probe, dancing dangerously close to the sun, tried to catch a glimpse. Its instruments detected faint increases in nickel particles, strange echoes of the earlier emissions, but nothing concrete. The Solar and Heliospheric Observatory scanned the same region, recording bright flares and coronal ejections. Hidden within those solar storms, something moved, but it blended so perfectly with the chaos that even the data analysts couldn't isolate it. Still, a few of them whispered that they saw a pattern, a brief flicker, a moving dot that traveled against the solar wind. Nothing natural travels against the Sunday, but no one mentioned it in the official report. Now picture the stillness of deep space during those months. The solar system turns, oblivious, planets tracing their endless loops, while this object, this enigma, passes in silence behind the great star. If you were floating out there, in that furnace of light, you'd see it not as bright green anymore, but as a dark silhouette gliding through the golden storm. The sun's corona shimmers around it, casting halos and shadows across its edges. It doesn't disintegrate, it doesn't break apart, it just drifts, steady and purposeful, almost like it's using the sun's blinding radiance as camouflage. Back on Earth, time stretches. Scientists mark days on calendars like sailors waiting for land. The online communities grow restless. Every post begins the same way. Any news, any updates, and every answer is the same. Not until December. For 2 months, humanity stares into the brightest light, hoping to see something hidden in it. It's almost poetic how easily knowledge can be burned away by illumination. When the object finally emerges on the other side, telescopes are already waiting. The first data points arrive. Brightness slightly lower, color shifted, tail configuration different. Some sigh in relief it survived the Sunday. Others furrow their brows it shouldn't have. Natural comets rarely endure perihelion so neatly. They fracture, lose mass, evolve. This one returns as if untouched, pristine, as though the sun's heat meant nothing. The papers will say, no significant anomalies. The analysts will say, within expected margins. But you, sitting here, know better. The timing, the symmetry, the precision, it all feels choreographed. Maybe 3I Atlas didn't just vanish. Maybe it was hiding on purpose, waiting for the one moment when the universe itself could cover its tracks. And maybe that's the real lesson of its disappearance, that the greatest secrets aren't buried in darkness. They're hidden in plain sight, behind the brightest light we know. In September, the public updates stopped. No more tracking logs, no more spectral data. Routine pause, the agency said. But insiders reported anomalous readings. Silence, after all, is its own kind of signal. It began quietly, as most disappearances do, not with alarm, but with absence. The official NASA blog, usually alive with graphs, telemetry charts, and carefully worded optimism, went still. Press briefings were postponed. The social media feeds that once shared dazzling images of 3I Atlas now offered only sunrises and motivational quotes. A short, operational pause, one statement read, followed by a full week of nothing. For a space agency whose heartbeat is data, the sudden quiet felt like holding your breath underwater. At first, no one thought much of it. Space missions often go dark for recalibration. But as the days passed, a strange unease spread through the astronomy community. Amateur observers noticed discrepancies in tracking schedules, gaps where observations should have been logged. A few reached out to NASA's public relations office and got polite replies that said everything and nothing. We are reviewing incoming data. Updates will resume shortly. No cause for concern. Words smooth enough to skate on. But inside the agency, not everything was smooth. Picture the control center in Pasadena. Rows of glowing monitors, the quiet buzz of filtered air, and a room full of scientists trying not to look nervous. The data feed from the Deep Space Network, usually a steady trickle of numbers, had started showing irregularities. signals dropping in and out, readings fluctuating in patterns, too clean to be random. Some analysts thought it was interference from solar activity. Others weren't so sure. One technician reportedly muttered, "It's as if something's talking back." The comment was ignored, the way unsettling things often are. In an internal meeting, an engineer presented a summary of the anomalies. The slide showed repeating sequences, brief spikes of electromagnetic energy, spaced evenly apart, each lasting a fraction of a second. The pattern repeated 6 times over 48 hours, too structured for static, too symmetrical for noise. Could be instrument drift, someone offered, but no one sounded convinced. The room filled with the sound of cautious pens clicking, the universal language of scientists about to bury an uncomfortable truth. You imagine what it must have felt like to be there. The fluorescent lights humming, the air conditioner sighing, everyone avoiding eye contact. The word signal hangs in the room like an uninvited guest. Nobody says it out loud, because saying it makes it real. So instead, they use safer phrases: coherent background fluctuation, non-random energy cluster, data irregularity, pending verification. Science, like politics, has its own poetry for the things it can't explain. By mid-September, the last public dataset was uploaded. Then nothing. No follow-up, no statement, no apology. The absence became louder than any announcement could have been. Journalists began asking questions, but NASA's press team replied with the same polite opacity. "We're analyzing." Behind closed doors, the agency's communication leads debated whether to address the growing speculation online. In the end, they chose not to feed the fire. After all, official silence is easier to manage than official uncertainty. Meanwhile, the rumors bloomed. Forums lit up with talk of cover-ups. A supposed leak claimed the readings weren't random at all, that the pattern corresponded to a frequency range rarely used in natural processes, one often reserved for spacecraft telemetry. "If this were a comet," the leaker wrote, "it's a very organized one." The post vanished within hours. Screenshots survived, as they always do. Even the usually skeptical astronomers began to wonder. The idea wasn't that 3i Atlas was broadcasting, it was that it might be reacting. Every time it was pinged by radar, the return signal came back slightly shifted, like an echo with a mind of its own. The deviation was tiny fractions of a second, but consistent. To most, it meant nothing. To a few, it meant everything. Outside the bureaucracy, the night skies stayed the same. Cold, endless, serene. Amateur astronomers kept watching. Their telescopes pointed toward the coordinates where 3i Atlas should have been. But now, even their feeds picked up interference bursts of static, irregular hums, faint distortions in otherwise clean recordings. Coincidence, perhaps, but you start to sense a rhythm, a pulse, like the universe clearing its throat. Inside NASA, a few younger engineers quietly saved copies of the anomalous data before it was archived. They didn't know what they were looking at, only that it didn't feel right to lose it. They whispered in break rooms, their conversations soft and conspiratorial, like kids sharing ghost stories at midnight. "Maybe it's nothing," one said. "Yeah," replied another. "But what if it's not?" The public silence stretched into weeks. When the agency finally spoke again, the statement was short, almost dismissive. Data irregularities attributed to software calibration. Normal operations resumed. No further details. No questions taken. Just closure, neat and sterile. The world moved on, satisfied, or at least distracted. But silence, once noticed, never really fades. It lingers, it hums, And in that hum, if you listen closely, you can almost hear what they didn't say, that maybe, just for a moment, the instruments caught a whisper from something that shouldn't whisper back. Every comet pushes itself slightly off course as it vents gas. 3I Atlas didn't budge. To resist that push, it would have to weigh 33 billion tons, 5 kilometers across, denser than physics should allow. A comet that massive shouldn't exist unless it wanted to. Imagine that. A wanderer from another star system, streaking through our solar neighborhood, shrugging off the very laws of motion. To anyone else, it's a faint streak on a CCD sensor, a smudge in a spreadsheet. But to those who notice, it's an insult to inertia, a cosmic boulder that refuses to drift. Comets, by nature, are restless. Their surfaces boil and spit as sunlight wakes the ices inside. Jets of vapor shoot from their crusts, like champagne from a shaken bottle, and that pressure nudges them, gently but measurably, off course. It's basic thermodynamics. Push out gas, move a little the other way. Every one of them dances this uneven ballet through the void. Everyone, except this one. The team at JPL ran the models 3 times, each time coming back with the same number, 33 billion tons. They stared at the result, like accountants finding a negative balance in the laws of physics. To be that stable, 3I Atlas would have to be not only enormous, but extraordinarily dense, made of material far heavier than rock or ice, something closer to forged metal. Imagine a steel mountain 5 kilometers wide, gliding silently through the dark. The math makes your mind itch. A comet that heavy should collapse under its own gravity, flatten itself into rubble, or at the very least, betray some hint of stress. But the data showed none of that. No spin instability, no wobble, no off-gassing trail, just steady, implacable motion. In scientific meetings, they called it a non-gravitational anomaly. But that phrase is a polite fiction, like calling a ghost sighting an optical incident. It means this shouldn't happen, and we have no idea why. One engineer reportedly muttered, "Either our software is broken or reality is." The others laughed, thinly, because humor is the last defense against the unknown. The problem wasn't that the object was weird, it was that it was too consistent. Nature is messy, noise is the rule. But 3I Atlas moved as if it had read the laws of celestial mechanics and decided they didn't apply. Picture yourself there, in one of those late-night labs. The fluorescent lights buzz softly overhead. Someone pours stale coffee into a mug that says, "I need my space." The graphs on the monitor look almost peaceful flat, steady lines where turbulence should be, and you realize something strange, that calmness itself is terrifying, because calm means control. And if something out there is controlling its motion through a solar system it doesn't belong to, then someone or something knows exactly what it's doing. Loeb, predictably, couldn't resist poking the wound. If it maintains its trajectory against solar pressure, he told a colleague, then it's either made of material we've never seen, or it's using propulsion. He didn't say it was a ship. He didn't have to. The idea hangs there like static in the air, unspoken but undeniable. The press, of course, didn't print that part. They rarely do. But within the quiet corridors of astrophysics, the phrase self-regulating trajectory became an in-joke, whispered like a campfire story. You can almost feel the absurdity of it, the universe presenting us with a math problem too heavy to lift. Every attempt to explain it ends up circling back to that same stubborn number, 33 billion tons. The the kind of mass you'd expect from a small moon, not a visitor from another star. One scientist, exhausted, compared it to throwing a refrigerator into a hurricane and watching it not move. Another said, "It's like the comet doesn't want to go anywhere." And maybe that's the point. Maybe 3I Atlas isn't traveling through space, it's waiting in it. Its steady course isn't inertia, it's intent. Its weight isn't burden, it's anchor. You start to wonder if mass itself could be a kind of camouflage. If something wanted to look natural, maybe it would simply pretend to be too heavy to question. The deeper the models go, the stranger the implications become. Its density suggests a core of metal alloy, nickel-rich, iron-poor, echoing that same unnatural fingerprint found in its spectrum. Not a rock, not ice, something engineered, or at least processed. The equations begin to whisper, this isn't debris, it's design. And so, the 3 billion-ton problem becomes more than physics. It becomes philosophy. How much can you weigh before the truth bends around you? What if intelligence doesn't announce itself with light or radio, but with silence and precision? Perhaps the surest way to hide is to move so perfectly that no one believes you're moving on purpose. By now, the astronomers have run out of ways to phrase the impossible. Unprecedented density, anomalous motion stability, potential structural cohesion, all polite ways of saying, we don't know what this is. The data sits on servers, encrypted and archived, waiting for the next generation of scientists to open it and stare, the way this generation did, half in awe, half in dread. Because here's the thing about space. It doesn't need to make sense. It just needs to exist. And yet, 3I Atlas doesn't merely exist. It persists. Against radiation, against heat, against reason. A comet that refuses to drift, carrying 33 billion tons of quiet defiance across the void. Whatever it is, it moves not because it must, but because it chooses. Mathematicians noticed something eerie. The object's path aligns with Mars's orbit to within 2.7 million kilometers. That's the cosmic equivalent of threading a needle from 1,000 miles away. Coincidence? Or rendezvous? It sounds like a question for late-night coffee and nervous laughter, but the math doesn't smile. Imagine plotting the solar system as a grand clockwork, planets swinging in their ellipses, asteroids drifting like dust motes between gears. Everything moves with predictability, with rhythm. And yet, here comes 3I Atlas, gliding through the machinery with surgical precision, matching Mars's orbit so neatly it might as well have been aiming. The probability of that alignment by chance tiny, the odds of maintaining it smaller still. And as the numbers were checked, rechecked, and rechecked again, one truth began to whisper. Either the universe just got very lucky, or someone did. Picture the mathematicians first, their offices glowing dimly at midnight, coffee rings blooming like galaxies across their desks. They're the kind of people who find comfort in chaos because it can be graphed. But when the simulation first spat out the alignment data, even they went quiet. A 2.7 million kilometer offset sounds like a lot, until you remember the scale. In cosmic terms, it's tighter than an archer's aim across continents. One researcher, staring at the results, simply said, "That's intentional," and then immediately regretted it, because scientists aren't supposed to use words like that. Mars, meanwhile, keeps orbiting, unaware that it's been cast as the potential host of a cosmic rendezvous. From its thin atmosphere, the sun looks dimmer, smaller, filtered through a haze of dust and distance. If you could stand on its ochre plains and look up at just the right moment, 3I Atlas would glide across the sky like a silent emerald ember, the kind of sight that would make ancient civilizations invent gods. The irony, of course, is that our modern civilization might be watching one. You can almost imagine it a cosmic ballet choreographed long before humanity learned to measure time. The object's trajectory curves just enough to intersect Mars's orbital plane, then steadies, maintaining a parallel drift for weeks. No random tumbling, no deviation. Perfectly smooth, like a satellite pacing its companion. But this companion isn't supposed to exist. The models all agree. Interstellar visitors don't do precision. They barrel through systems like lost travelers, deflected by whatever gravity they meet. They don't thread orbital lanes like seasoned pilots. Loeb, ever the poet of improbable physics, suggested the obvious quietly. If it were aiming, Mars would be the perfect test. It wasn't an announcement, just an offhand musing over dinner. The kind of sentence you toss into the air to see who flinches. Mars, after all, is the one planet we've colonized remotely. It's filled with sensors, rovers, transmitters, all politely humming their telemetry back home. If something wanted to listen in, to observe our technology, to take a peek without knocking on Earth's door, Mars would be a fine balcony seat. And 3i Atlas took it. You might be tempted to laugh. It's too cinematic, too precise. But the numbers are stubborn. The orbit alignment isn't vague. It's quantifiable. The anomaly report notes that the approach vector followed the Martian plane with a variance of less than 0.01 degrees. In astronomy, that's not close. That's intentional. The official papers, of course, buried the phrasing in jargon. Coincidental spatial overlap with Martian orbital path. A sentence so carefully worded you can hear the fear of its own implications. Imagine being the one who noticed it first, some quiet analyst, deep in a simulation lab, watching the orbit model bloom on their screen. The red circle of Mars, the fine white line of 3i Atlas, and then that perfect intersection glowing like an omen. You'd stare at it for a long time. Then you'd check the code, then the math, then your own sanity. Because if the object's path wasn't coincidence, then something or someone out there knows exactly where Mars is. And here's where things get quietly unsettling. When 3i Atlas emerged from behind the Sun, its path didn't deviate as expected. No gravitational drift, no measurable drag. It didn't simply pass by Mars's orbit, it slid into it. It matched speed within a fraction of a percent. That's like throwing a dart from one moving car into another moving car's open window, while both are driving around the Sunday. Nature doesn't do that. The data teams were split. Some insisted it was a trick of perspective, an illusion born from orbital geometry. Others whispered what they wouldn't dare publish, that maybe the object was adjusting, that maybe, somewhere between invisibility and observation, it had changed course just enough to synchronize. And if that's true, then coincidence isn't just unlikely, it's impossible. Out in the cosmic quiet, Mars keeps turning, its orbit steady as always. Dust storms swirl, satellites blink, rovers crawl, and somewhere near that invisible path, 3i Atlas drifts silently, neither arriving nor leaving, neither comet nor visitor, just a steady companion keeping its distance too close to ignore, too quiet to understand. In the end, science will call it alignment, probability, celestial choreography, but you and I might call it what it feels like, a rendezvous. Because sometimes, even the cold mechanics of space can look suspiciously like intention, and sometimes the universe keeps its appointments. Loeb proposed the simplest, strangest idea. What if 3i Atlas isn't one object, but two, a mothership and a scout? The main body distracts, while smaller probes dart ahead, invisible to telescopes. The logic is unnerving. It's exactly how we'd explore another system. You can almost hear the silence that followed when he said it. The kind of silence that only exists in conference rooms, where the future has just been suggested out loud. One researcher laughed, softly. Another coughed. Someone pretended to check their email. Because once you say probe, you're no longer in the realm of comets and chemistry. You're in the territory of intent. And intent is terrifying. The probe hypothesis didn't appear in an official paper, at least not yet. It began as a thought experiment, a late-night conversation between colleagues who'd stopped pretending not to be curious. Loeb's reasoning was unsettlingly tidy. If an advanced civilization wanted to explore a foreign solar system without detection, sending small autonomous sensors ahead of a larger carrier would make sense. The carrier could coast quietly, emitting the faint signature of a comet, nickel-rich, iron-poor, a perfect cosmic disguise. The scouts, tiny and maneuverable, could peel off near a planet, dip through its magnetic field, collect data, and return unseen. In other words, it's exactly what we would do if we could. Imagine it from the outside. The cold darkness of space, absolute silence. 3. Atlas gliding smoothly along its impossible path. Then, from its surface or from somewhere near it, a faint shimmer, a ripple in the sunlight. Something small, smaller than a car, smaller than a human, detaches and begins to move with intention. No engines, no flare, just the soft drift of controlled inertia. It slides into shadow, aligning with Mars's orbit, unseen by any camera, too small for radar, too fast for comfort. Somewhere, millions of miles away, the mothership or comet, or whatever it is, keeps glowing faintly green, a magician's distraction in the dark. The scientists who entertained Loeb's idea didn't do it out of belief. They did it out of exhaustion. Because when you run out of natural explanations, the unnatural starts looking responsible. The alternative was chaos physics breaking in ways that shouldn't be possible. And yet, Loeb wasn't claiming aliens. He was claiming logic. If the simplest explanation fits the data, you at least have to consider it. We assume we're the first, he wrote once. But what if we're not even early? The reactions were predictable. Half the academic community rolled their eyes. The other half quietly checked their telescopes. The public, though, loved it. The phrase mothership and scouts trended for days, buried under memes and late-night talk show jokes. One host quipped, "If they're scouting us, I hope they brought snacks." But beneath the laughter was something else, fascination. Because deep down, humanity loves the idea of being watched, as long as it's from far enough away. Picture Loeb at his desk, late at night. The lights are dim. The air hums with the quiet buzz of electronics. He's staring at orbital simulations, tiny dots crawling across the screen like ants on glass. He zooms in on one of them, a faint anomaly that doesn't belong to any known debris catalogue. It flickers once, then disappears. He saves the file, labels it Scout Candidate, and closes his laptop. Outside his window, the sky over Massachusetts is clear. The stars look peaceful, but somewhere beyond them, something might be looking back. In theory, the idea isn't impossible. We already send probes into deep space with autonomy. The Voyager craft, Pioneer, New Horizons, each one a whisper of human curiosity, drifting between the stars. If we've done it with our technology, imagine what a civilization 1,000,000 years older could do. Their probes might be the size of pebbles, running on quantum power, self-replicating in silence. We wouldn't see them, not because they're hidden, but because they're smarter than our attention span. One small, grimly funny moment came during a press Q&A. A reporter asked, "So you're saying this comet might be spying?" Loeb smiled. That quiet academic smile that says, "I know how this sounds." "I'm saying," he replied, "it might be gathering information. That's what nature does. That's what we do." And for a second, no one laughed. Because he wasn't wrong. Curiosity is the universal constant across species, across stars. The probe hypothesis remains officially unacknowledged, filed under speculation. But behind closed doors, mission planners began double-checking trajectories, reviewing telemetry gaps, asking questions they'd once considered science fiction. One engineer whispered, "What if one of the scouts landed on Mars?" Another said, "Then we've already been met." And that thought, that quiet, humbling thought, hung in the air like static, impossible to erase. So maybe that's what 3i Atlas truly is. Not an invader, not a threat, just a messenger, traveling the long dark between civilizations, gathering whispers from planets that think they're alone. The silence of space isn't emptiness, it's listening. And maybe, just maybe, something out there has been listening longer than we've been speaking. Comets grow tails that trail behind them, pushed by solar wind. 3i Atlas did the opposite. Its tail faced forward, as if being pulled or guided toward the Sunday. Nature rarely does this. Engineers might. The first images looked like mistakes. Telescopes from Hawaii to Chile reported the same thing. The glowing plume of 3i Atlas wasn't streaming out behind it like the long, elegant brushstroke of every other comet in the catalogue. It was leading, like a banner carried into battle, or like a creature leaning into a wind no one else could feel. Astronomers blinked, checked their calibration settings, then checked again. Same result. The tail wasn't being pushed. It was being led. For a while, the official explanation was comfortingly boring: solar interaction variability, which translates loosely to, "We don't know, but the sun probably did it." But deep down, everyone knew the sun didn't do it. The tail's direction wasn't random. It adjusted, slowly, subtly, but unmistakably. Over the course of days, it reoriented itself with the grace of something that understood vectors. If a comet is a rock on fire, this one behaved more like a pilot with a plan. Imagine standing in an observatory, late at night, the kind of night where the world feels smaller than the universe would like you to believe. You look up at the raw data on your screen, spectral lines humming, pixel grids glowing faintly, and there it is again, the tail, facing forward like a spotlight cutting through the void. You try to explain it to yourself. Maybe a magnetic anomaly, maybe dust dynamics, maybe wishful thinking, but the image refuses to stop looking intentional. One astronomer called it the celestial equivalent of driving backwards down the freeway with headlights on. Another, more poetic, said, "It's like the comet is sniffing its way toward the Sunday." The humor helps, but only slightly, because if you think about it too long, it stops being funny and starts being personal. What if it is sniffing? What if the universe has finally sent something that behaves more like a drone than debris? The press barely touched it. After all, comets are easy to ignore. They come, they glow, they fade. The public interest lasts about as long as a trending hashtag. But within the astronomy community, the discussion turned quiet and electric. Group chats full of physicists suddenly filled with cautious emojis. "Has anyone confirmed this orientation shift?" one wrote. "Confirmed," another replied. Then a pause. "Don't quote me. There's a running joke in astrophysics. If something in space makes sense immediately, you've done the math wrong." This one didn't make sense at all, because even when factoring in uneven sublimation gas venting from one side more than the other, the tail's movement still resisted every model. It wasn't drifting chaotically, it was pivoting, slowly, deliberately, as though responding to the sun's position, not fleeing from it. Picture it now, suspended in space. The comet's body glows faintly, surface metals shimmering like frost on steel. Around it, dust spirals forward, forming a thin, luminous spear pointed sunward. Solar wind should scatter it, tear it apart, send it streaming backward, but the dust clings. The plasma sheath around it hums faintly, caught between magnetism and mystery. It looks less like a tail and more like a torch, its glow steady, unwavering, almost defiant. At JPL, someone runs a simulation and gets something eerie. If the object's rotation matches the data, its forward tail aligns precisely with the orbital plane, like a sensor aimed at the sunday. If it's collecting data, someone jokes, but no one laughs, because that's exactly what it looks like. A probe adjusting its field of view. Theorists try to find natural analogues. One suggests electrostatic repulsion, another proposes plasma reflection, but none of them fit neatly. Comets don't track, they drift. This one tracks. It's almost beautiful, in an unnerving way, the image of an object falling toward the sun, but watching it at the same time, as though studying its host star like a biologist peering into a petri dish. Loeb, of course, couldn't resist commenting. "If it's artificial," he said in an interview, "this is what I'd expect to see, a reflective surface facing the energy source." He said it so calmly, you might have missed the weight of the sentence. The interviewer chuckled awkwardly and moved on. But those words stayed, because once you imagine it, a machine turning its face toward the sun, it's hard to unimagine. Maybe it's nothing. Maybe 3i Atlas just happened to vent gas in precisely the right configuration to create the illusion of intelligence. Maybe it's just a cosmic trick of light. But part of you doesn't buy it, because nature rarely writes symmetry into chaos, and this thing, this comet, keeps finding ways to look symmetrical. It's not proof of intent, but it's the kind of coincidence that makes coincidence feel lazy. So now, when astronomers look at that tail pointing forward through the black, they can't help but feel the tug of a quiet thought. Maybe it's not a tail at all. Maybe it's a signal. Or maybe it's a steering plume, an invisible hand on the rudder of the void. After all, when something points the wrong way for long enough, maybe it isn't wrong at all. Maybe it's just facing home. From July to August, the nickel emissions increased 25-fold. No other comet has ever done that. Something on its surface was changing, fast, burning, reacting, or maybe operating. At first, the readings were dismissed as calibration drift, the kind of quiet data hiccup that gets fixed with coffee and patience. But the spike didn't go away. It grew sharper, more insistent, like the heartbeat of something waking up. The spectral lines thickened until they looked like exclamation marks written across the stars. Nickel, pure, metallic and furious, glowed where there should have been the soft chemical chaos of dust and ice. The scientists stared, blinking through fatigue, and someone whispered what no one wanted to say. It's increasing, actively. Picture it, the James Webb Space Telescope, floating in the deep, its golden mirrors aimed at a single flicker in infinity. Every photon it collects tells a story, but this one sings louder than expected. Nickel is supposed to be subtle, a background hum in the song of creation, but 3i Atlas was shouting. Between July and August, the emissions didn't just grow stronger, they grew structured. The spikes appeared in intervals, almost rhythmic, not random, a pattern. It's the kind of discovery that makes a scientist's pulse race and their stomach drop at the same time. Because nature is beautiful, but it doesn't keep time that neatly. At first, the community tried to contain the excitement. A few preprints appeared online with careful titles like Unusual Metallic Activity, Observed in 3-Eye Atlas. The tone was polite, measured, terrified. Then the peer reviews began, and the tone shifted. Instrumental contamination, one reviewer wrote. Unphysical interpretation, another said, which is the academic way of calling someone crazy without having to spell it. But the numbers didn't care about reputations. They just kept glowing. Imagine standing on its surface now, if such a thing were possible. The horizon curves away beneath your feet, dark and glittering. Beneath a paper-thin crust of dust, a glow pulses faintly, like molten veins under translucent skin. The nickel vapor rises in invisible ribbons, curling into the cold vacuum, shimmering like liquid mirror. You run a hand along the surface and feel warmth, a steady vibration, as though the rock itself is humming with quiet effort. You take a step back, and there it is, a soundless eruption of light, not chaotic, but organized, like machinery cycling through an old, forgotten routine. Somewhere, in an office at Harvard, Loeb looks up from his calculations and smiles the tired smile of someone who's seen this movie before. He types a single line into his notes. Sustained emission, consistent with industrial process. He knows what it sounds like. He also knows it fits the data. Because in physics, when you see a process you can't explain naturally, the next reasonable guess is intention. Maybe it's refining, he tells a colleague. Refining what? The colleague asks. Nickel, Loeb says. Or maybe just itself. The world, predictably, reacts with equal parts awe and disbelief. The headlines flip between awe and ridicule. Alien smelter in space, and astronomers lose their minds over metal rock. But behind the jokes, a truth gnaws. The emissions are real. The pattern holds. Whatever 3-Eye Atlas is, it's doing something consistent, something controlled. Every model that tries to explain it through thermal venting or photodissociation ends up collapsing under its own contradictions. The simplest explanation that something intelligent is happening remains unspoken, not because it's absurd, but because it's terrifyingly plausible. You can almost imagine the conversation between scientists late at night. If it's real, it's technological. If it's technological, it's not from here. And if it's not from here, silence. Coffee cups clink. Someone stares at the screen as if it might blink back. Outside, the world spins quietly, oblivious, as humanity debates whether the universe just turned on a light. By late August, the nickel surge plateaus. The emissions stop increasing but remain impossibly high. It's as if the process, whatever it was, finished. Some say it ran its course. Others whisper it completed its task. When the signal flatlines, the graphs look eerily peaceful, like a heart monitor that's finally gone still. For a few days, the scientific community feels relief until someone points out that the object's albedo, its brightness, has also changed. The surface, once dull and mottled, now gleams faintly, as though coated in fresh metal, not shedding mass gaining it, as though it was reinforcing itself, not burning away. And that's when the theories shift again. Maybe it wasn't venting. Maybe it was building. Maybe 3-Eye Atlas was recharging, plating itself in armor made from its own reserves. The idea is absurd, beautiful, and deeply unsettling. Because if that's true, then the comet isn't dying. It's preparing. So the nickel surge fades, the headlines drift, and the world returns to its routine of pretending not to notice the extraordinary. But the data remains etched in servers, copied in notebooks, printed in quiet labs. And every so often, a young astronomer pulls it up on their screen, stares at that spike, and feels the hairs on their arms rise. Because no matter how much time passes, one question never stops echoing. What burns nickel in the cold of interstellar space? And why? During its solar eclipse, only one craft, the Parker Solar Probe, could possibly glimpse it. For a few brief hours, it did. The data are classified. The official reason, instrument calibration. The unofficial reason, no one agrees on what it saw. Picture it, a machine no bigger than a small car, orbiting closer to the sun than any human creation has ever dared. The Parker Solar Probe moves through a world of fire, its shield glowing white-hot, its instruments trembling against waves of radiation that could erase a lesser thing from existence. During one of its perihelion passes, its sensors were aimed precisely where 3I Atlas should have been hidden behind the blinding halo of the sun, invisible to every eye on Earth. For 2 hours, the instruments picked up something. Not light, not heat, something else. Then the data stopped. At first, NASA's Solar Division announced a temporary blackout due to solar interference. A few hours later, a second statement appeared. Routine instrument calibration. The tone was steady, the phrasing identical to half a dozen other reports from other missions. But within the quiet corners of the astrophysics community, rumors began to hum like feedback. A junior systems engineer claimed the probe's magnetometer spiked briefly, sharply before cutting out. Another said the plasma readings displayed structured modulation, like a pulse wrapped in sunlight. Both statements vanished from the internal logs within days. The official files now show nothing unusual, which, if you've been paying attention to this story, is the surest sign something was. Imagine the scene from Parker's perspective. The sun fills its sky, a roaring sea of plasma waves. Light is not light here. It's pressure, it's weight, it's noise. And somewhere within that light, a shape drifts, dark against the impossible glare. Not a silhouette, exactly more like an absence of radiance. A void that refuses to shine. A moving shadow in a world that shouldn't have shadows at all. The onboard sensors register fluctuations, not random, not chaotic, but regular, periodic. The kind of signal that looks like heartbeat data if you tilt the graph just right. Then, silence. The transmission cuts mid-packet. When it resumes, the data logs are clean, like a record that's been wiped and rewritten. Engineers later described the blackout as expected. But telemetry doesn't lie, it just obeys orders. Somewhere in those missing minutes, the probe saw something it wasn't supposed to. Maybe just a plasma knot, maybe a reflection, maybe something else entirely. But in the weeks that followed, Parker's instruments behaved strangely. 2 sensors needed recalibration. A third started producing phantom readings measurements without source, echoing faintly at the same frequency as 3I Atlas's earlier nickel emissions. They were written off as electronic ghosts. That's the official term, phantom data. But the engineers who handled it gave it another nickname, the Whisper. Now picture the meetings. Closed doors, fluorescent hum, the room full of people who've seen enough strangeness to know better than to speak too freely. We'll call it interference, says one. Solar flares, says another. It's always solar flares. Laughter, thin and nervous, the kind that fills the air, just enough to keep it breathable. But someone leans forward and asks the question no one wants to hear. What if it wasn't interference? What if it was interaction? The silence that follows lasts longer than protocol allows. Back on Earth, the story fades into technical papers. The calibration logs are clean. The graphs are smooth. Yet something about the timing refuses to line up. The probe's blackout corresponds exactly within seconds to the period when 3I Atlas was geometrically aligned with the Sun's lower corona. Too precise to dismiss, too awkward to explain. Loeb, when asked about it, smiled and said, "The Sun is the best hiding place in the solar system." The reporters laughed. The scientists didn't. For months after, faint anomalies ripple through the deep space network. Tiny phase shifts in radio transmissions, too small to matter, too patterned to ignore. One technician swears she saw a signature, a repeating modulation buried in the static. She prints the waveform, tapes it to her cubicle, and labels it window glint. Her supervisor tells her to remove it. "We don't name interference," he says, "but names have power, and this one sticks." Among the small, quiet community of people who stare too long into the dark, the missing Parker data becomes legend, the invisible window, the few hours when something looked back through the Sunday. What it saw, no one knows. Some whisper, it wasn't a comet at all, but a reflection, something metallic hidden within the solar wind, revealing itself only at the right angle. Others think the probe caught a fragment of its own shadow. But there's another theory, one that lingers like heat after light, that 3I Atlas opened something, not a door, not a signal, but a window, a brief alignment between a machine made by us and something made by someone else. And for a few fragile moments, across 150 million kilometers of fire, the two might have seen each other. Then the light shifted, the window closed, and the universe went back to pretending nothing happened. We've found only 2 interstellar objects before this one. Finding a third so soon and so large defies probability by a factor of 100,000. Either the universe just likes to surprise us, or something is sending a message in sample size. You can almost hear the weary sighs of astronomers everywhere as the math started whispering nonsense. Probability, after all, is supposed to keep the universe civilized. It's the referee between order and absurdity, the polite reminder that lightning doesn't strike twice, and definitely not 3 times in the same century. But 3I Atlas refused to care about statistics. It came roaring, or rather gliding, into our solar system like a cosmic punchline to a very old joke, because, according to everything we know, it shouldn't be here. Not yet. Not again. Not like this. Imagine sitting in a dimly lit office, surrounded by the scent of burnt coffee and slow panic. On one monitor, spreadsheets of orbital mechanics stretch like spiderwebs. On another, probability models collapse into question marks. The math insists this object's arrival is nearly impossible. The data insists it's very real. It's like winning the lottery 3 times in a row, one astrophysicist mutters, except the prize is an existential crisis. The first interstellar visitor, Oumuamua, was supposed to be our once-in-a-lifetime anomaly. The second, Borisov, made us think maybe we'd gotten lucky twice. But 3I Atlas? That's not luck. That's choreography. If randomness is the universe's handwriting, this event reads like calligraphy, too elegant to be an accident. Statistically, the odds of detecting 3 interstellar bodies in just a few years are so low that entire probability charts had to be redrawn. It's like the cosmos started dropping breadcrumbs, daring us to notice the pattern, and when you start plotting their trajectories, something strange happens. They don't scatter randomly, they align, not perfectly, but eerily close like beads on a thread, strung across the galactic plane with just enough symmetry to keep mathematicians awake at night. Loeb, of course, leaned back in his chair and said what everyone else was too afraid to. If you were sending probes through a galaxy, he mused, you'd release them along predictable trajectories. Let gravity do the distribution. He wasn't claiming conspiracy, just geometry. But geometry, when it gets this neat, starts to feel like intent in disguise. If a child draws 2 dots on a page, it's random. If they draw 3, you start to see a triangle. The human mind loves patterns, but sometimes the patterns love us back. Now, imagine standing outside under a clear sky, the air still, the stars sharp as glass. Somewhere out there, 3 messengers from the deep drift silently between worlds. One cigar-shaped, one ghostly blue, one shimmering green, each discovered by accident, each rewriting the odds. You can almost feel the weight of their coincidence pressing against your ribs. Maybe it's nothing. Maybe it's just the universe flexing its creativity. But maybe, just maybe, it's coordination. The deeper the data dives went, the stranger it got. The detection probability for 3I Atlas, given its size, speed, and reflectivity, was roughly 1 in 10 million per observing year. The chance of seeing it within the same decade as Oumuamua and Borisov, practically 0, a cosmic joke without a punchline. Yet here it is, glowing defiantly in our skies, as if statistics were just a suggestion. One scientist compared it to flipping a coin 30 times and getting heads every single time. Another said, if randomness were music, this is jazz, played by an alien mathematician. Of course, the official line stayed cautious. Our detection sensitivity has improved, they said. We're just getting better at finding these things. It's a comforting story, and maybe even partly true. But the improvements don't account for this frequency, nor for the fact that each new interstellar object seems to grow more complex, more deliberate. It's as if the universe keeps raising the difficulty setting on its riddles. If you squint, you can almost see a sequence emerging. First, the silent cigar of Oumuamua, smooth, quick, uninterested in sunlight. Then Borisov, the icy wanderer, a classic comet with just enough strangeness to whisper that something was off. And now 3I Atlas, bright, structured, behaving less like a drifter and more like a visitor. Its evolution written in starlight, each one a test, each one a little louder. By the time the models stabilized, the astronomers were left staring at a paradox they didn't want to name. Either interstellar visitors are far more common than we ever imagined, or they're far more interested than we ever hoped. Probability says no, observation says yes, and in that quiet contradiction, you can almost hear the universe chuckling to itself. Maybe this is how first contact actually happens, not with a signal or a landing, but with math. Not a message carved in stone or transmitted through radio, but written in the impossible rhythm of discovery. The numbers don't lie, but they do tease. And if you listen closely enough, if you trace those orbits long enough, you start to see it, the faint geometry of attention. Something out there has noticed us. Or maybe, more humbling still, we've finally started noticing it. October came and went. Mars Reconnaissance Orbiter recorded its data, and then nothing. The images haven't been released. Some say they were too low resolution. Others say they were too clear. The story begins, as silence always does, with a promise of more to come. In early October, the astronomy bulletins were still cheerful. MRO would swing into position, its high-resolution imaging science experiment, high-rise, ready to capture the most detailed look yet at three eye atlases close pass by Mars. Scientists waited for the usual flood of photos, pixel-sharp streaks, dust trails, maybe even a faint green shimmer. Instead, the feed stopped at the download confirmation screen. The next update came 2 weeks later, and it contained nothing but calibration data, grey boxes, static fields, empty frames that looked more like modern art than science. Officially, the explanation was mundane: transmission loss, thermal noise, data truncation due to solar interference. The phrases were so familiar they almost rocked the world back to sleep. But not everyone bought it. You see, the timestamps didn't match. The telemetry logs showed the cameras firing perfectly, and the transmission strength steady. Nothing dropped, nothing failed, which means the silence wasn't accidental. It was curated. Imagine the control room that night. Red-eyed engineers staring at monitors, the air humming with machinery and anticipation. On the main screen, a tiny moving dot crosses the Martian sky. The tracking lock holds. Someone leans closer, adjusting the focus. The raw image streams begin a flood of data, more than expected. Then, a flicker. One frame freezes, another distorts, a third brightens so violently that it blows out the contrast. When the pixels stabilize, something appears beside the comet. Not a flare, not a dust plume, something shaped, geometric. For a fraction of a second, it hovers, then vanishes as if erased. A technician whispers, "That can't be real," and someone else says, "Don't log it." The feed is cut. By morning, the internal message boards are scrubbed clean. Only a handful of people still have the raw files, and even they can't agree on what they saw. One describes a triangular halo. Another says it looked like a lens reflection with intent. Whatever it was, it lasted less than a blink, but changed the tone of every meeting that followed. When reporters asked for updates, NASA's spokesperson smiled the weary smile of someone rehearsing disbelief. The images were unfortunately below quality thresholds. And that was that. No scandal, no leak, just the soft thud of official closure. But silence, once noticed, begins to echo. A few days later, amateur radio listeners in Australia picked up stray packets matching MRO's telemetry band. The signals were faint, but complete, too complete. When decoded, they revealed frame headers that didn't correspond to any known transmission set. 6 frames missing, each time-stamped within the window of the flyby. The data blocks were encrypted, something MRO rarely does for raw imagery. The files became known in certain corners of the internet as the October 6. No one could open them, but everyone had theories. Some said it was classified military interference. Others said it was proof of what MRO actually saw: a structure, a pattern, maybe even motion. Imagine being one of the image analysts tasked with reviewing those missing frames. You sit in a darkened lab, the hum of the cooling fans filling the space where conversation used to live. You scroll through line after line of spectral data, looking for mistakes. But the only mistake you find is that nothing is wrong. The instruments worked flawlessly. The silence isn't the result of failure, it's the result of choice. Someone, somewhere, decided the world didn't need to see what Mars saw. Loeb, of course, couldn't resist weighing in. In a quiet interview, he said, "When information disappears, it's often because it revealed something new." He didn't accuse anyone. He didn't need to. The words carried their own gravity. Scientists are cautious with imagination, but the idea lingered that perhaps 3I Atlas had shown us something we weren't ready to understand. You can almost feel that weight now, the hush between facts, the quiet hum beneath official calm. Maybe the images truly were useless, the blur of motion and glare washing everything away. Or maybe they were too perfect, too crisp, too precise to fit into the comfortable chaos of the natural universe. So October ended the way all mysteries do, not with revelation, but with red tape. The data remains locked, the archives sealed under the dull phrase, instrument calibration. Yet, out in the silence of space, 3I Atlas keeps moving, indifferent to our curiosity. Whatever those missing frames contain, dust, geometry, or something stranger, they're still out there, orbiting Mars in the form of memory. And for now, the only thing we can see clearly is the absence itself. Twitter, Reddit, and every astronomy forum became a battlefield. Artifact, cried one camp. Comet, cried the other. Memes of Loeb in sunglasses spread faster than data tables. But under the noise was a quiet question. Why does this one feel different? You could almost chart the chaos by timestamp. The first post was a grainy gif of 3I Atlas's trajectory, captioned, "Guys, the tail's pointing the wrong way." The second was an all-caps reply, "Bro, it's just solar wind." Within hours, the thread had devolved into a philosophical street fight, disguised as science, where PhDs argued with high schoolers, armed with Wikipedia citations and existential dread. It was beautiful, in the way a slow-motion car crash of human curiosity always is. For days, timelines overflowed with theories. Someone posted a graph comparing 3I Atlas's movement to Oumuamua's, claiming the angles matched perfectly. Another zoomed into a pixelated image until it looked vaguely hexagonal, declared it a hull panel, and tagged Elon Musk for verification. The comments filled instantly. Confirmed alien drone, obvious compression artifact. You people need hobbies. But the truth was that everyone involved already had a hobby, this one. The thread count doubled hourly. Arguments flared, cooled, reignited. Reddit servers groaned under the weight of people simultaneously screaming data integrity and wake up sheeple in the same comment chain. Meanwhile, Avi Loeb, unwilling meme star and reluctant prophet, became the internet's favorite Rorschach test. His calm academic tone was cut into thousands of clips, edited with techno music and green lasers, captioned, "Professor of Possibility." He didn't even need to tweet anymore. His eyebrows had their own fan accounts. When he said in an interview, "We should follow the evidence wherever it leads," it was remixed into lo-fi beats, motivational TikToks, and, inevitably, someone's ringtone. Loeb was everywhere and saying almost nothing new, because he didn't have to. The internet had already decided what he meant. The beauty of online debate is that no one has to be right to feel victorious. On one side, scientists and skeptics clung to Occam's razor like a life raft. Extraordinary claims require extraordinary evidence. On the other, enthusiasts and dreamers whispered the heretical inversion. Extraordinary evidence might already be here. We just don't know how to see it yet. Somewhere between them was the rest of us, refreshing pages, watching the same grainy footage for the 15th time, wondering why it made our skin crawl. You can almost see the scene in miniature. Thousands of humans, each sitting alone in dim rooms lit by blue screens, all staring at the same handful of pixels and projecting their own fears and hopes onto it. Some see math, others see meaning. Some laugh, others pray. The internet hums like a nervous beehive, buzzing with analysis, sarcasm, and a touch of collective insomnia. By week 2, the debate fractured into factions so specific they sounded like religions. There were the tail truthers, who insisted the forward-facing plume proved propulsion, the reflectivity realists, who argued it was all just ice behaving weirdly, the nickelheads, devoted entirely to the purity of its metallic spectrum, and, inevitably, the Lobians, who just liked the aesthetic of believing in mystery. They made t-shirts, 70% technological probability, they said, in bold green text. Somewhere out there, an Etsy shop paid rent entirely because of one man's academic caution. But underneath the noise, the memes, the think pieces, the YouTube thumbnails screaming, NASA cover-up, something quieter pulsed, a collective intuition that this one felt different, not because of the data, but because of how the data refused to behave. Every other discovery could be explained away eventually. This one kept slipping through the cracks of reason like sand through a fist. It glowed when it shouldn't, hid when it shouldn't, acted like it had read our textbooks and decided to improvise. Imagine scrolling late at night, long after you should have stopped, the glow of your phone screen washing your room in ghostly light. You don't even know what you're looking for anymore, proof, maybe, or reassurance. Every few posts, someone says, "It's just a rock," and you want to believe them. But then you see that one image again, the green shimmer, the geometry, the impossible symmetry, and you feel it, that quiet hum behind the noise, the one that says, maybe not. Loeb, for his part, stayed calm. Whether it's natural or not, he said in a webcast, it's teaching us to look differently. He might as well have been describing the internet itself. The debate wasn't about what 3i Atlas was. It was about what it meant for us to be the kind of species that couldn't stop arguing about it. In a way, the object had done something miraculous. It made humanity look up again. And so, amid the chaos, the hashtags, the memes of Loeb, photoshopped onto a UFO with the caption, "I told you so," something subtle unfolded. For the first time in years, millions of people were united not by fear, but by fascination, not by certainty, but by curiosity. Because whether 3i Atlas was a rock, a relic, or a rendezvous, it had already done what all great mysteries do. It reminded us that the universe is still bigger, weirder, and more wonderful than our arguments about it. Infrared readings from NASA's SphereX mission showed something no comet ever shows: a single, bright point. No tail, no blur, just a glowing dot in the dark, steady and deliberate, like a headlight in space. It shouldn't have been possible. Comets are messy by nature, all dust and vapor and drama, shedding material like an exhausted traveler scattering breadcrumbs through the void. They smear across the sensors, they blur, they flicker. But this one 3i Atlas was a minimalist, a singularity of light where chaos should have been. The universe is full of noise, but this was focus. The SphereX team first noticed it during a calibration sweep. The telescope was supposed to be mapping diffuse infrared background radiation, the soft glow of distant galaxies, not the pinpoint perfection of something so close. One analyst thought it was an error. Another thought a cosmic ray had hit the detector. But when they checked the next exposure, the dot was still there. Same place, same brightness, same eerie precision. It didn't fade, didn't flicker, didn't move the way comets drift. It just was, steady, deliberate, patient, like something that knew how to hold still. Imagine the tension in that control room, scientists leaning forward, the soft rustle of keyboard clicks breaking the silence. One engineer magnifies the image until the pixels bloom like cells under a microscope. The edges are perfect, too perfect. Maybe it's a star, someone offers, but the coordinates don't match any known object. Maybe a glitch, another says. But glitches don't repeat across multiple instruments. Spherex runs the same region again hours later. The dot remains. Identical. Immaculate. In astronomy, steady is almost a dirty word. The sky moves. Everything shifts. Even the most stable stars tremble under the weight of their own fusion. But 3i Atlas radiated with the confidence of something engineered for stillness. The team ran through every natural explanation they could think of: reflective ice core, directional venting, solar albedo, even the rare phenomenon of forward scattering dust. None fit. The spectrum was too clean. No water vapor, no dust, no gas, just pure metallic emission, humming like a tuned instrument in the dark. When the report circulated internally, the tone was clinical, but the subtext wasn't. Anomalous point source behavior, inconsistent with known cometary physics. Translation: we have no idea what we're looking at, and we're afraid to call it what it looks like. One scientist, unable to resist, scribbled in the margin, "Headlight?" Another circled it and wrote simply, "or I." You can almost see it, the glowing dot, suspended against the infinite backdrop of space, unblinking. It doesn't flare, doesn't fade, doesn't play by the messy improvisation of nature. It looks, instead, like intention. Imagine floating nearby, watching this quiet beacon pulse steadily, its light reflecting faintly on your suit. There's no warmth, no hum, no sense of movement, just presence, like standing in a dark room and realizing the mirror is looking back. When the anomaly leaked, because secrets in science always do, the internet responded in its usual, spectacular fashion. "Alien flashlight," said one post. "Cosmic laser pointer," said another. But the professionals stayed silent, as they often do when words start to sound like belief. The official NASA response was 3 sentences long. Spherex recorded a unique point source event consistent with metallic reflection. Additional data required for confirmation, which is the bureaucratic equivalent of shrugging while sweating. Behind the scenes, more troubling details emerged. The brightness of the point fluctuated, but not randomly. The variation followed a perfect interval. Once every 19.3 hours, the light dimmed slightly, then returned to full strength. It wasn't pulsation, it was rotation. The kind of modulation you'd expect from a spinning object with a single reflective facet. It was as though something on 3i Atlas was turning a panel, a dish, a mirror, catching sunlight, redirecting it deliberately, rhythmically. At this point, even the skeptics started to sound tired. Coincidence, one said. Natural periodicity, but their voices lacked conviction. Because deep down, everyone knew that comets don't turn like lighthouses. They tumble, they wobble, they decay. This one kept rhythm, precision, purpose. The more data came in, the stranger it got. The reflection wavelength shifted slightly with each spin, suggesting surface modification, metal heating, cooling, reacting. It looked less like reflection and more like calibration. One physicist, young, sleepless, and not yet fully afraid of career suicide, summed it up in a private message to a colleague. "It's behaving like an instrument, not an object." The reply came minutes later. Then what's it measuring? That's the question that lingers. Because even now, the light persists. Spherex continues its scans, the point source glowing steady as a metronome in the deep. Some call it noise, some call it coincidence. But for those who've stared too long at that clean, unflinching dot, it feels like something else. Not a comet, not a coincidence. A signal patient, silent and perfectly composed. Whatever 3i Atlas is, it doesn't blink, it doesn't explain, it just watches. And maybe that's what unsettles us most. Not the brightness itself, but the way it seems to hold us in its steady gaze, as if we are the ones being measured, one rotation at a time. If the calculations hold, it will re-emerge from behind the sun in early December. Telescopes are waiting. So are we. Because if it comes back off course, even by a fraction, we'll know it wasn't drifting. It was steering. Astronomers don't usually speak of waiting, as though they're expecting an old friend to return from a long voyage, but that's exactly how it feels. The world's observatories, from the Atacama Plateau to Mauna Kea, are like sentinels standing in the dark, facing the east, waiting for a familiar ghost to reappear from the furnace of the Sunday. They've been patient for months, running simulations, recalibrating optics, pretending not to be nervous, because this isn't just another comet rounding the corner of its orbit. This is a test. The universe has given us an appointment in December, and everyone's pretending it's routine. The timing couldn't be more poetic. Early winter skies, long nights, cold air, telescopes humming quietly like monks chanting in infrared. December is the month of revelation and reflection, when things hidden by the light begin to re-emerge. But this time, the object that vanished isn't just expected, it's anticipated like a verdict. If 3i Atlas reappears exactly where physics predicts, the story ends quietly. Another oddball rock, another lesson in cosmic humility. But if it's even slightly off its expected path, just a hair, a whisper, a cosmic shrug in the wrong direction, the implications shift from curiosity to choreography. Imagine the scene, midnight in Chile. The VLT array sits under the thin desert air, its dishes turned toward the horizon, where the sun has just dipped away. Operators whisper to each other in the dark, their faces lit by soft blue screens. Somewhere in the data feed, photons that left 3i Atlas minutes ago are being captured, converted, catalogued. Every few seconds, a soft ping marks another observation, each one a heartbeat in a suspense story written across millions of kilometers. Any deviation? Someone asks. Too early, another replies. They all nod. They know what they're waiting for. Motion, with intent. In labs across the world, the calculations are printed and taped to walls. Predicted trajectory arcs, like elegant brushstrokes. The margins filled with anxious scribbles. If deviation is greater than 0.01 degrees, non-gravitational. Those two words, non-gravitational, hang like prophecy, because gravity is the one rule everything obeys. Everything natural, at least. But to move in defiance of it, to alter course deliberately, that's the cosmic equivalent of a wink. Even the public feels it now, that strange anticipation, humming through astronomy forums, YouTube live streams, even coffee shop conversations. It's supposed to come back soon, right? People ask, pretending it's just small talk. They scroll through telescope feeds, check star charts, watch for any headline with the word update. There's a low collective electricity in the air, the same quiet excitement people felt when Oumuamua first darted past. Except this time, the feeling is older, heavier, like we're not just watching a rock, but waiting for an answer. Imagine 3i Atlas now, emerging from the glare. The sun behind it burns like an enormous curtain of fire, and from that curtain comes a spark. Slowly, faintly, the point of light brightens, steady as breath. Astronomers hold their own breath. They compare, they overlay, they whisper. The coordinates align almost perfectly, almost. A fraction of a degree, less than the width of a fingernail held at arm's length. It could be nothing thermal drift, solar wind, instrumental bias, or it could be intention, a nudge, a whisper that says, "I'm not following your map anymore." If that happens, if the trajectory bends even slightly, the conversation changes overnight. Not just in labs and journals, but in living rooms, because steering implies decision, and decision implies agency. The thought alone is enough to make even the most grounded scientists stare a little longer into the night sky before locking up the observatory. Loeb, when asked what he'd do if 3i Atlas returns off course, smiles faintly. "I'll update the probability," he says. "Maybe 75%. It's a joke, but the kind that hides truth behind math. Because once you cross a certain threshold of unlikelihood, the universe starts to look suspiciously self-aware. Meanwhile, December inches closer. The sun drifts south. The nights stretch longer, and telescopes around the world wait like open eyes in the dark. Somewhere between skepticism and wonder, humanity holds its collective breath. Maybe the comet will return as expected, silent and obedient, gliding along its predicted arc. Or maybe it will shift just enough to remind us that even the sky, vast and ancient, can still surprise. And if it does, if that bright, unblinking light appears a few pixels to the left of where it should, there will be a moment, brief but unforgettable, when millions of people feel it at once. That strange mix of awe and recognition, the whisper that maybe we've been noticed. Then, the screens will glow brighter, the data will pour in, and the story will begin again, not of what we found, but of what found us. Physics explains motion. Intent explains deviation. To scientists, intent is taboo, the line between natural and designed. But every line blurs eventually, and if 3i Atlas acts like it knows what it's doing, maybe that's a line worth blurring. The first time someone said it out loud in a late-night conference call, half lit by laptop screens, the virtual room went completely silent. Intent. The word hung there like static, buzzing just beneath the hum of academic restraint. Someone cleared their throat, another changed the subject, but the thought had already landed. Because physics can tell you where something's going, how fast it's moving, and what forces are acting on it, but it cannot tell you why. Intent is the forbidden fruit of astrophysics. To suggest that something out there might be acting with purpose is to step across an invisible line, one drawn not by data, but by discomfort. Scientists don't like why. It's messy. Why belongs to philosophers, poets, and people who think crop circles are intergalactic signatures. But every so often, an anomaly appears that quietly whispers, "Ask anyway." 3i Atlas is one of those. Imagine the data numbers spilling down a screen like rainfall. Every measurement tells a story, and this one sounds eerily human. Course corrections so subtle they might be random. Rotational stability that shouldn't persist in an object so irregular. Even its bright nickel emissions seem timed, pulsing faintly in intervals that look accidental until you realize they aren't. Not perfectly periodic, but consistent enough to tease pattern, like a hand tapping absent-mindedly to music we can't hear. At first, the community resisted the notion of intent, the way a body resists infection. Papers emerged with comforting phrases like non-gravitational outgassing and electrostatic influence. They were elegant, polite, and wrong. The data refused to conform. The trajectory shifts didn't match venting patterns. The energy curves didn't flatten where they should. Every new explanation solved one problem by inventing another, a kind of mathematical whack-a-mole. each hypothesis collapsing under its own elegance. Loeb, predictably, became the first to stop pretending the question wasn't there. If something behaves as though it's making decisions, he said softly during an interview, maybe we should treat that as more than coincidence. It wasn't a claim, it was an invitation. But the word decisions hit like a comet of its own, fast, hot, and impossible to ignore. Some colleagues called it reckless, others called it refreshing. A few, quietly, called it obvious. Because deep down, the unease had already spread. 3i Atlas didn't just move, it chose. Imagine, for a moment, that you could hover beside it. The void is quiet. Sunlight curls faintly around its edges, glinting off what looks like ice, but reflects like metal. It's turning, not tumbling, but rotating with poise. Each revolution measured. You can feel it not just motion, but deliberation. The same way you can tell the difference between wind and breathing, between noise and a song. You can't prove it, not yet, but something about the rhythm feels alive. Not in a biological sense, but in the way a clock is alive when it keeps perfect time. Intent changes everything. A drifting rock is curiosity. A steering one is conversation. And that's where things get uncomfortable. Because if 3i Atlas is acting with purpose, then we are no longer merely observers, we are participants. We are being seen. It's a shift so profound that even the equations seem to hold their breath. Theologians, philosophers, and science communicators all began to circle the topic like cats around a closed box. Maybe it's automated, one said. Like a probe. Maybe it's self-correcting, said another. Like evolution. The irony, of course, is that both of those imply the same thing. Design. Whether biological or mechanical, something had to build it, or at least program it to care about direction. And caring is the ghost of intent. By December, a few bold preprints began to circulate with cautious titles, modeling non-random trajectories in interstellar objects. The phrasing was delicate, almost apologetic, as if the authors were whispering intelligent behavior through cupped hands. But the tone was shifting. A taboo, once named, starts to erode. Even the most traditional physicists began adding footnotes like, behavior suggests active control, not yet fully understood. Not yet. 2 words that taste suspiciously like hope. You might think the world would panic at the thought of an object acting on purpose, but oddly, it didn't. Instead, there was wonder, a sleepy kind of awe that settled over late-night news shows and cafe conversations. People looked up again, not out of fear, but curiosity. Because maybe, after all this time, the universe isn't silent. Maybe it's been talking softly all along, and we're finally learning to listen. Intent, once dismissed as superstition, now hums at the edge of our understanding, a question we can't quite unask. Whether it's a machine, a relic, or something beyond our vocabulary doesn't matter yet. What matters is that somewhere in the dark, a quiet traveler might be steering not by instinct, but by choice. And if so, then we aren't alone in asking why we're just the newest ones to ask it aloud. A few engineers have proposed a compromise. Maybe it is natural, but made of the wreckage of something artificial, a fragment of a civilization long dead, drifting through eternity like a cosmic shipping container with the lights still on. It's an elegant kind of madness, the way the mind reaches for meaning when numbers stop behaving. And for a brief moment, the scientific world and the poetic one shook hands. The idea wasn't that 3i Atlas was a ship or a probe or even alive. It was that it might be junk, ancient, inert, and impossibly old. Not the messenger of intelligence, but its fossil, It started as a joke, as these things do. A materials engineer on a late-night panel half smiled and said, "Maybe it's scrap metal." The audience laughed. The moderator moved on. And yet, the phrase lingered. Because it fit. Nickel, without iron, structured emissions, and that strange refusal to disintegrate under the sun's glare. Nature makes chaos. Industry makes alloys. What if this wasn't a comet at all, but the spacefaring equivalent of a rusted can washing up on a cosmic shore? Imagine it now, floating quietly through the void, a vast, battered husk of something that once had purpose. Panels long torn away, compartments fused by heat, circuitry reduced to crystal veins. Its insides hollowed, its systems sleeping, its trajectory unfeeling. The remnants of a civilization's reach, now reduced to a drifting tombstone. The industrial comet. They started calling it a phrase that sounds absurd until you look at the data and realize how uncomfortably literal it might be. In the vacuum of space, metal doesn't rot, it endures. Radiation weathers it. Impacts scar it. But nothing truly kills it. A machine, abandoned and unpowered, could last for eons. Entire civilizations could rise and fall before its next encounter. Maybe 3I Atlas isn't from a living civilization, but one long erased, a fragment of a dead culture that mastered the stars, only to leave behind their garbage, floating between them. The universe, after all, has never promised tidiness. Back on Earth, the idea split the community into two distinct moods. The romantics, who saw melancholy beauty in the notion of alien ruins, and the pragmatists, who called it nonsense with slightly trembling voices. A wreck implies origin, they said. An origin implies company, and no one likes that implication. Because if something built this thing, and it's been drifting for millions of years, it means time and distance haven't protected us. They've only delayed the reply. Loeb, ever the quiet optimist, described the idea as the middle path. If it's artificial, he said, it doesn't need to be active. A fragment of technology could outlive its makers. So could its purpose. That last sentence sent shivers through the audience. Because purpose is the one thing we can't measure. What purpose does debris serve after it forgets itself? What task does a derelict probe continue when its mission and its creators are dust? Picture it moving through the dark like a relic of an empire that never knew us existed. Its surface pitted, reflective in patches like old chrome, glowing faintly as sunlight grazes its seams. Maybe once, it was part of something enormous, a construction scaffold, a mining drone, a starship hull. Maybe it broke apart in some forgotten war, flung into interstellar exile, destined to drift forever. Or maybe, more eerily, it was never part of a war at all. Maybe it simply outlived everything else, the way metal sometimes outlives memory. The metaphor writes itself. The cosmos as a scrapyard, and we curious, fragile apes, staring at one of its relics, wondering if we too will one day become someone else's anomaly. Perhaps, one distant epoch from now, a new species will detect the Voyager probes and say the same thing. Natural, but suspiciously well made. Of course, the industrial comet theory is still fringe, whispered about more in midnight conference calls than in published papers. But it's spreading. Because it bridges the impossible gap between comfort and awe, it lets scientists stay grounded while still peering into the mystery. It allows for both rationality and wonder, the two halves of curiosity that always argue but never separate. And so, the theory persists. 3. Atlas might not be alive, but it might have been built by something that once was. It's not a visitor. It's an inheritance, a cosmic relic drifting through time's long silence, whispering that maybe intelligence doesn't end it, just oxidizes slowly across the stars. And as our telescopes prepare for its return, humanity can't help but stare into that faint green shimmer and ask the question that unites engineers, dreamers, and insomniacs alike. What if the universe's first message wasn't a word, but a piece of debris saying we were here, once too? 2 days after the flyby, Mars Express detected a brief spike in background radiation near the pole. Officially, cosmic rays. Unofficially, a 3-second burst that shouldn't exist, coming from exactly where 3 I Atlas had just passed. The spike was so short, so sharp, that it was almost overlooked. A blip in the constant hum of interplanetary noise. The kind of data point that usually gets filed under statistical anomaly, buried beneath calibration reports and cosmic dust. But one analyst in Darmstadt noticed it, an intern, technically who wasn't supposed to. They compared timestamps, cross-referenced positions, and realized something uncanny. The burst came not from the sun, not from Jupiter's magnetosphere, but from the direction of the comet's path. The official log described it clinically: transient energy, increase, localized, non-repeating, duration 3.1 seconds. Translation: something shouted into the dark, once, and then went quiet. Normally, that's the end of the story, but this signal had edges, sharp ones. Natural radiation doesn't do that. Cosmic rays scatter, flare, fade. They are chaotic by nature. But this spike had structure: a rise, a plateau, a fall, 3 clean beats. It looked less like a burst of energy and more like a transmission. Of course, no one could say that out loud. The European Space Agency knows the gravity of words. Transmission becomes event, pattern becomes profile. And so, the report called it non-random but non-repeating, a phrase so careful it might as well have been whispered through a locked door. Still, the pattern refused to disappear. Within hours, data scientists across continents were quietly mirroring the files before they vanished behind access restrictions. They found harmonics subtle but present like echoes nested inside the spike, too organized for chance, too brief for error. Imagine standing at Mars's North Pole, in that eternal dusk of red dust and thin light. The air is electric. Somewhere above, invisible waves ripple across the sky, unseen but unmistakable. For 3 seconds, the planet hums a vibration not of sound, but of signal. Then silence. The desert resumes its ancient stillness. You wouldn't even notice unless you were listening very closely. And Mars Express was listening. The official press release arrived 2 weeks later. No anomalous readings detected. That was the line: simple, final, wrong. But the scientists who had seen the data knew better. Some of them spoke off-record to colleagues. If it was cosmic rays, one said, they were the most disciplined rays in the solar system. Another, with dry humor, added, maybe space learned Morse code. It's easier to laugh than to admit you've glimpsed the unexplainable. Loeb's reaction was characteristically calm. 3 seconds is enough for a message, he said, when asked. Enough for a test ping. He didn't elaborate. He didn't have to. Because if the signal was deliberate, even in the smallest way, then the implications reached beyond data. It meant interaction. It meant something saw Mars, passed near it, and perhaps wanted to see if anyone was listening. Back on Earth, decoding efforts began unofficially. Amateur radio astronomers got hold of frequency approximations, feeding them through every spectral analysis tool they could find. Most found nothing. A few claimed faint patterns resembling binary intervals, too weak to prove, too neat to dismiss. The theories multiplied like spores. "It's a reflection," said one camp. "No, it's an echo," said another. "No, it's intentional," whispered a third. But the third group never said it loudly. They never do. Imagine the scene in those labs again. The data scrolling like a pulse on a heart monitor, a rhythm repeating inside the noise. 1, 2, 3. Stop. Nothing else. The silence that followed was almost heavier than the signal itself. Because nature doesn't care about rhythm. Nature doesn't count to 3. That's a human thing. Or at least, an intelligent thing. The most unsettling part came later. Cross-analysis with the Mars Reconnaissance Orbiter logs showed a faint electromagnetic echo, a delay of exactly 1.7 seconds after the Mars Express burst. The two weren't supposed to be communicating. They weren't even on the same frequencies. Yet the data lined up perfectly, like call and response. It was subtle, almost plausible, and completely absurd. And just like that, the burst became a legend. The Mars signal. Of course, the story faded quickly. Officially, nothing happened. But in astronomy circles, when nothing happens, it tends to leave a mark. The burst remains in the archives, buried in the fine print. The kind of thing that only shows up if you know where to look. And every now and then, someone runs the numbers again, just to make sure. 3 seconds. A pulse that came from nowhere, pointed exactly where 3I Atlas had been. Too short to decode, too deliberate to ignore. Maybe it was nothing. Maybe Mars just sneezed. Or maybe, just maybe, the universe cleared its throat before saying something we're still not ready to hear. If it reappears, what will we see? A comet, tattered and dull, or something sharper, quieter, watching from the edge of sunlight? The odds, as Loeb put it, are 70% chance of the unexpected. That's a comforting number until you realize no one knows what unexpected means. The phrase itself became a kind of riddle among astronomers. How do you quantify surprise? What does a 70% likelihood of astonishment even look like? Somewhere, a graduate student tried to plot it in a spreadsheet, realized halfway through that it was an existential question, and quietly went for a walk. December has always been a month of anticipation of lights returning to the dark, of things emerging from long shadow. And now, it carries another kind of waiting. Telescopes everywhere, optical, infrared, radar, are trained toward the same invisible point. Their domes like great metal petals turning toward a sun that hasn't quite risen. 3I Atlas has been gone for months, hidden behind the sun's glare, its absence a silence that hums. But soon, the sky will tilt, and it will step back into view. Every scientist with a telescope and an overworked laptop is quietly holding their breath. Imagine it, the early hours before dawn, frost clinging to the observatory railings, the air so still, you can hear the hum of electronics. The data streams in slowly, like whispers returning from the void. And somewhere in those photons, humanity's question lingers. What are you? The first glimpse will come not to a scientist, but to a machine, a pixelated trace, a flicker in the noise, a single dot refusing to behave. Humans will follow minutes later, hearts rising as the graphs unfold. And then the first realization will ripple outward. It's back, right on time. Or almost, because that's where the drama lives, not in the sighting, but in the offset. Even a fraction of a degree, even 1,000th of a second of delay, would mean everything. Drift is ordinary. Deviation is deliberate. If 3I Atlas returns precisely on its predicted path, physics wins. But if it doesn't, if it comes back a little to the left, a little brighter, a little different, then the cosmos itself, might be confessing something. The data analysts call it positional variance. The poets call it behavior. You can almost picture the faces of those scientists as the first numbers appear, hope disguised as skepticism. Someone mutters, "There it is." Another says, "Wait, that's odd." And someone else, half joking, whispers, "Define odd, because that's the problem." No one agrees what counts as unexpected. Is it a green glow again? A shift in brightness? A forward tail? A pulse of nickel emission? Like a heartbeat we've learned to anticipate, but not explain? Or is it something quieter, no change at all? Just the unsettling sense that it knows we're watching. By now, the world has joined the vigil. News anchors smile nervously as they repeat Loeb's words about a 70% chance of the unexpected, as though it's a weather forecast for cosmic weirdness. Social media hums with speculation, some scientific, some poetic, all sleepless. Memes circulate. Can't wait to be unexpectedly expected. Someone makes a song using the word 70% as a looped refrain. Another user posts, "What if the unexpected is just ourselves?" and gets 20,000 likes from people who don't quite understand it but feel it anyway. Loeb himself, in an interview conducted by Lamplight, said something that stuck. Maybe the unexpected isn't in the object. Maybe it's in how we react to it. He meant it philosophically, but people took it personally. Because beneath the equations, the graphs, and the cautious press releases, there's a quieter story unfolding. Humanity waiting for an answer it can't articulate. Not proof of aliens or validation of theories, just acknowledgement. A nod from the dark. Picture December's night sky, the stars brittle and clear. Somewhere behind the sun, 3i Atlas turns slowly, its surface cooling, its reflection shifting from green to silver. It's neither hiding nor announcing itself, it's simply obeying whatever ancient momentum still drives it. And yet, on Earth, millions of minds are watching, wondering if this will be the moment something changes, the moment the familiar becomes impossible again. Because that's the paradox of discovery. We want the universe to surprise us, but not too much. We crave the unknown, as long as it behaves politely. But if 3i Atlas comes back even slightly wrong, too fast, too steady, too aware, then we'll have to admit something we've avoided for centuries, that maybe curiosity goes both ways. So, we wait. We watch the horizon brighten. We run the numbers again, knowing the numbers can't prepare us. And when that first glimmer breaks through the solar haze, when the object steps out from behind the light, no one will say a word. Because for all our telescopes, theories, and sensors, the question remains disarmingly human. What will we see when the unexpected finally looks back? Humans love certainty almost as much as we love fear. 3i Atlas gives us neither. It sits at the intersection of both a cosmic Rorschach test for our hopes and our paranoia. Maybe the truth isn't out there. Maybe it's in how we react to not knowing. Every great mystery ends up saying more about the audience than the answer, and this one is no exception. You can almost imagine the universe smirking, arms crossed, watching us debate in comment threads and conference halls, each of us projecting our insecurities onto a glowing speck of metal and ice. We call it science, but it's really therapy with equations. When 3i Atlas first appeared, the scientists wanted numbers, the philosophers wanted meaning, the internet wanted memes. And between those three tribes, something strangely honest unfolded. A collective confession that uncertainty, for all its terror, is intoxicating. We claim to fear the unknown, yet we build telescopes to chase it. We fund space missions, just to flirt with confusion. It's as if we need the universe to keep secrets, so that we have a reason to keep getting out of bed. Imagine sitting under a cold December sky, telescope humming quietly, coffee cooling beside you. The stars feel sharp, precise, knowable. And then there's that faint shimmer again, the one no model can predict. Your mind runs through the possibilities. Maybe it's just dust, maybe it's reflection, maybe it's something that once had purpose. But then you pause and realize the most important word in that sentence isn't something, it's maybe. Because that's where the human brain thrives, in the space between explanation and imagination. Loeb once said in an interview, "Science isn't about certainty. It's about curiosity disciplined by humility." The internet promptly cut the quote down to, "Science isn't about certainty," and added laser eyes to his photo. It's both tragic and perfect, because the edited version describes us better than the real one. We want humility from our scientists, but drama from our mysteries. We say we crave truth, but what we really crave is tension, the kind that keeps a story alive. And 3, iAtlas gives us exactly that, the story without the ending. The panic isn't really panic, it's ritual, a cultural heartbeat that thumps louder whenever we brush against something bigger than us. What if it's alien? What if it's not? What if we never know? Each question loops back on itself like an anxious prayer. The scientists write cautious papers, the press writes overconfident headlines, and somewhere in the middle, we sit refreshed by the absurdity that the cosmos still has the decency to surprise us. It's tempting to think of panic as weakness, but in this context, it's proof of imagination. We panic because our minds can hold more possibilities than our equations can. We panic because hope and dread share the same corner of the brain. The philosophers call it the sublime, the beauty of something vast enough to terrify us. The psychologists call it cognitive dissonance. The poets, if we still had enough of them, would probably call it a good night for staring upward. Picture it, the world quietly buzzing with unease. In labs, scientists whisper about data gaps. Online, strangers argue about propulsion theories. A high school student somewhere in Manila writes an essay titled, "What if it's looking back?" and gets an A. A retired engineer in Germany stays up all night refreshing NASA's feeds, muttering, "I knew it." The panic, when you zoom out, looks less like chaos and more like connection, a global pulse synchronized by curiosity. The philosophy of panic is simple. Uncertainty binds us. It's the one constant that democratically unnerves everyone. It flattens hierarchy. Professors, bloggers, astronomers, and insomniacs, all staring into the same abyss, all equally uninformed. In that sense, 3i, Atlas, has already achieved something profound. It's made humanity briefly honest. For once, no one is pretending to know. And in that rare stillness of collective ignorance, there's a strange peace. Loeb, in one of his calmer moments, summarized it beautifully. If we ever stop being uncomfortable, we stop learning. Maybe that's what the object really represents. Not evidence of life, but evidence of our willingness to keep wondering. The panic isn't a flaw in the human condition. It is the human condition. To care enough about the unknown to lose sleep over it. To argue about its meaning while secretly hoping we're wrong, because being right would end the thrill. So maybe panic isn't the opposite of peace. Maybe it's the prelude, the heart beating faster before understanding catches up, the inhale before revelation, or before bedtime. Because the truth, when it finally comes, if it ever does, will be quiet. And in that silence, we might miss the noise of minds churning, the soft chaos of curiosity, the noise that makes us human. And if 3i Atlas has taught us anything, it's that the unknown doesn't scare us as much as the idea of running out of things to wonder about. And so we arrive at the strangest thought of all. Maybe it isn't visiting us. Maybe we've finally come close enough for it to notice us, to turn, ever so slightly, in our direction. Because for all our telescopes and data, the question remains, what happens when the observer becomes the observed? It's the kind of thought that feels like a whisper in the back of the mind, the kind that makes you glance at the night sky and suddenly feel very seen. 3i Atlas isn't moving fast anymore. Its path has slowed, its brightness stabilized. It's drifting in the stillness between orbits exactly where we can see it best, almost like it chose the spotlight. When you point a telescope at something, you rarely think about reciprocity. You're just collecting light, catching ancient photons in a mirror bowl. But somewhere in that silent exchange, light bouncing off something far away, light landing in your eye, there's a quiet symmetry. What if the gaze goes both ways? What if the light we catch isn't just reflection, but recognition? Scientists don't like to phrase things that way, but the universe is under no obligation to respect our comfort zones. Imagine 3i Atlas suspended in the cold. Its surface glints with a pale green sheen, its rotation so steady it borders on deliberate. For months, it's been silent, predictable, maybe even patient. But now, as it rounds the inner orbit, something subtle changes, a shift in reflectivity, a pulse in infrared readings, rhythmic, faint, deliberate. It's as if the object were blinking once every few hours, too regular to be random, too slow to be signaling. Or maybe that's exactly what a signal would look like from something that thinks differently, less in words, more in timing. Loeb, of course, refuses to call it communication. It's probably natural, he says, voice even, expression unreadable. But he doesn't say it with conviction, he says it with hope. Because if 3i Atlas is doing what it appears to be doing watching us, it's not a discovery, it's a realization that we are no longer looking at a distant rock, but at something aware of being looked at. The idea spreads quietly through labs, not as panic, but as reverence. A few astronomers even start referring to it, half-jokingly, as the mirror. Picture that, humanity staring into space, and space staring back, with all the patience of time itself. For centuries, we've been broadcasting our existence, radio waves, satellite pings, atmospheric signatures shouting into the dark. But what if the dark finally blinked? Not as threat or greeting, but as acknowledgement. The poets would call it destiny. The scientists would call it data. The rest of us would simply call it a moment. In the observatories, the air hums with restrained awe. Data analysts compare readings, skeptical eyes betraying quiet wonder. The fluctuations line up across instruments separated by thousands of miles. Coincidence, one says. Pattern, another replies. And in between those two words lies the entire human condition, the need to explain, and the fear of succeeding. Because what if this is it? The thing we've spent millennia searching for, not proof of life, but proof of attention. There's a strange tenderness in the idea that something out there might have noticed us, not as conquerors or curiosities, but simply as fellow beings staring into the same abyss. Maybe 3i Atlas isn't a machine, or a relic, or a weapon. Maybe it's just a witness, a traveler drifting through the dark, recording civilizations the way comets record the chemistry of stars, collecting light, storing stories, moving on. If that's true, then we've already been written down in its memory. Somewhere, encoded in a pattern of reflected light, is our silhouette, our noise, our brief electric signature of curiosity. The paradox is perfect. The closer we look, the less certain we become of who's doing the looking. Telescopes turn, lenses focus, graphs bloom with precision, and yet the sense of control quietly dissolves. Because once you entertain the possibility of being observed, the experiment changes. We aren't studying the universe anymore, we're participating in it. The observer effect, famous in quantum mechanics, now feels like philosophy made manifest. When you watch something long enough, it changes. When something watches you back, so do you. It's funny, isn't it? For all our fear of being alone, we never stop to consider the equally haunting alternative that maybe we never were. Maybe the reason 3i Atlas feels so different isn't because it's watching us for the first time, but because it's finally letting us notice that it's been watching all along. So here we are, Earth turning slowly under a December sky, telescopes blinking like eyes that have just realized they're being seen. The numbers roll in, the graphs rise, the glow persists. Somewhere above, a dot of light drifts through the silence, unwavering. It doesn't speak, it doesn't move, it simply exists, steady, patient, reflective, like a mirror held up to our own curiosity, like the universe saying softly, "Now you know how it feels."